You found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on this.
Hey there YouTube, the Dapper Dinosaur here. I am here once again looking at a talk by Andrew Snelling. I'm not sure what it is about his particular brand of dishonesty, but it really bugs me. And it's been something like a year from the time of my writing this that my last video about him was published, which means it'll be well over a year between that and this one being made public. So I thought it was time to revisit him. Today he's talking at Quentin Road Baptist Church, which is in the Chicago area. The topic is about how apparently science confirms a young Earth. And I have cut out the particularly churchy stuff at the beginning and end, including a hymn and a bunch of church announcements that aren't really relevant to us. That still leaves us with well over an hour of Andy Snelling though, so let's just dive right in.
Science confirms that the Earth is young, just as the Bible teaches.
Weird how the scientific world seems not to have noticed that, isn't it?
So we're going to start dealing with the issue of the age of the Earth, and we'll circle back to what the scriptures say later on.
I think people who watch me regularly already know this, but some of you might be new to this channel, so let me tell you how I feel about what the Bible says about a topic. I like the Bible. I read it. I have some knowledge of the original languages. I like to talk to biblical scholars, and I have more than one video about the Bible and what it's trying to convey. That being said, when it comes to science, nothing matters less to me than what the Bible has to say on a topic. Reality isn't beholden to the Bible, neither is science, as a study of the natural reality of the world. When it comes to science, what I care about is twofold: the data and what people who know more than me about a topic have to say about that data. That might not be obvious to me as a layman in basically every field, although I like to think a well-read and intelligent layman. And no, before you ask, I am not in my estimation a linguist, a paleontologist, or a historian, despite being mistaken frequently for either of the first two and having a degree in history.
But most people don't realise
that young Earth creationists even exist, because not only are they a minority among Christians, they make absolutely no difference in the world of science at all, except as annoyances.
the age of the Earth, they think that the geologists have proven it because they've measured it based on the dating of Earth rocks.
I think most people have just never worried about it. Not that they have a positive belief that it was measured by measuring rocks on Earth. As I'm sure we're about to be told, it wasn't. It was measured by dating meteorites, since the whole solar system formed at about the same time according to every model of solar system formation that I'm aware of. So meteorites should be about the same age as Earth overall.
And it's proven, therefore, that the Earth is 4.57 billion years old. But most people don't realise that the Earth's age was never determined by dating Earth rocks.
That's kind of true, but only kind of. The oldest rocks that originated on Earth that have been found are the rocks of the Acosta Gneiss in the Canadian Shield. They are some 4 billion years old. This means that whether or not we accept the slightly older dates derived from meteorites, we have a minimum age for the Earth of 4 billion years. This might be a good argument if all the rocks on Earth were under 6 or 10,000 years old, and all we had were the meteorite dates to indicate a far older age for the Earth. But that's not the situation. Also, this is unrelated, but I have to say I like the design on that lectern. It's basically the church's logo, which itself is well balanced and nicely symmetrical. Whoever designed that logo did a bang-up job, in my opinion.
That must surprise you. You would think the geologists have found the oldest rocks on Earth and that's the age of the Earth. No.
It's close. The actual date is only about 13% older than the date we'd get by just going based on known Earth rocks. It's like guessing that someone is 40, but they're actually 45. Sure, it's not right, but then is it actually that big of a deal? It certainly doesn't mean that you should have actually guessed that they were born an hour and a half ago, which is what Snelling is doing with the age of the Earth.
The Earth's claimed age was not derived from Earth rocks. It was actually derived from meteorites.
Yeah, I know, and so does everyone watching, because I can actually get to the point.
From a group of meteorites, the radioactive dating of a group of meteorites. And here it is. It was in the mid-1960s. Claire Patterson at Caltech, he uranium-lead dated, or lead-lead dated. Lead-lead dating is using the two uranium, there's uranium-238 and uranium-235. that have two different lead end members, and we'll come back to that in a moment, so I'm already talking big science.
I wonder if he'll mention the fact that according to his own on-screen graphic, an isochron dating technique was used, which uses different dating methods but also involves plotting the isotopic ratios on a chart to see if they form a linear distribution, which if they do, rules out leaching and contamination, which are common things creationists complain about when attempting to discredit the science of radiometric dating.
But he dated the Earth as a result of meteorites. Now, that's a problem because, you see, he was assuming that the meteorites represent the Earth when it formed.
Well, more the solar system as a whole, not just the Earth. But that's the implication of pretty much every idea of solar system formation that's ever been put forward in science. I know Snelling would prefer the magical explanation, but that's not how science works. He'll need a better reason to discard things like the nebular hypothesis than just, well, my interpretation of my favorite book is at odds with gravitational collapse, so I think it's dumb.
But we know that's wrong.
No, he doesn't. He's just confident it's wrong. You see, knowledge is the subset of belief that is both true and well-founded. Snelling's beliefs about this are neither true nor well-founded. You'll notice that confidence doesn't come into it. If you believe something that's true and you have good reason to think it's true, but you're not terribly confident that you're right, you still know that thing. This is why I hate the Dawkins scale of atheism. It confuses knowledge for confidence, and it makes both the words atheism and agnosticism more confusing and less helpful.
Because, you see, they assume that the Earth and the solar system formed at the same time, flung out of the sun as a hot molten blob.
Nope, no one thinks the solar system was flung out of the sun as a hot blob. The sun condensed from a cloud of mostly hydrogen, but not all of the cloud ended up in the sun. The debris that was moving fast enough to orbit the protosun formed a disk, and differences in gravity within that disk caused other objects to collapse and form, including the planets and asteroids.
But you see, they're wrong. Why are they wrong?
Because Andrew Snelling thinks the Bible disagrees with reality, and so it's reality that must give way.
See, they're assuming an evolutionary history.
Only in the broadest sense. Evolution isn't just a synonym for science that shows that young Earth creationism is wrong. They're assuming a previously well-supported hypothesis. That's normal in science. When Snelling goes to identify a rock sample he took, he assumes things like the hardness and streak color of rocks that have been previously defined. He doesn't have to go around and demonstrate the whole Mohs hardness scale or redo every single streak test. He can just reference previous and currently uncontested work in his field. That's true for science broadly. If you don't like the hypothesis that is used as the basis of the research, whining that it was the basis of the research isn't going to do anything. You actually have to do something to refute the underlying assumption that is itself the conclusion of previous science.
To then prove that evolutionary history, by the way.
Yeah, that's how science works. If you want to test a hypothesis, you assume it's true, calculate the consequences of that, and then check your calculation against reality with either subsequent observations or experiments. If reality is close to your predictions, then you have provided evidence that you were right. If it is not, then either your hypothesis is wrong or incomplete, or you've done your calculations incorrectly. Once again, we have a PhD creationist evincing a fundamental lack of understanding of the basics of how science works. I do not believe that Snelling is actually confused about this. I think, based on both his education and other things I've responded to from him, that he's simply misleading his audience.
But they're wrong. Why? Because the Bible says that in the beginning, God created the heaven and the earth.
Okay, Bible stuff. I don't care. Empirical evidence or get out. After this, he just complains that the order of creation in Genesis 1 isn't what reality indicates it is. I don't care, because what's in the Bible isn't the standard in science. Hell, it's not even really the standard in Snelling's theology, since his theology is willing to just ignore parts of the Bible that are inconvenient, such as James 2:4, which flatly says that the classic Protestant doctrine of sola fide is wrong. If Snelling isn't going to take James seriously in theology, I see no reason to take Genesis seriously in science, especially since the Bible is at least trying to talk about theological matters, whereas I am not convinced it could be reasonably said to be even attempting to talk about scientific matters in virtually all passages.
But it also assumes that the radioactive dating of rocks...
That's radiometric, not radioactive dating.
...is an accurate measure and it works perfectly. Well, it doesn't.
Yes, it is accurate, and nothing works perfectly, nor does anyone assume that it does. We check. And one of the great ways we can know that it's accurate is that it's economically vital. Oil exploration is a big industry with high stakes. A successful oil well is a huge moneymaker. but they're so expensive that drilling a dry well can be a disaster. As a result, companies doing oil exploration pay a lot of people a lot of money to look for promising drill sites, and the age of the rocks is a huge part of that. The age is determined by both index fossils and radiometric dating. If they weren't accurate and reliable, then drilling oil wells would be unreliable. As a contrast, we can look at Zion Oil and Gas, which decided to base their drilling locations on the Bible, and as a result bought a bunch of oil rights in Israel and drilled dry well after dry well, because, spoiler, the Levant doesn't have a lot of oil in it. I mean, Syria has a fair bit, but even then its oil reserves pale in comparison to those of Saudi Arabia, Canada, the United States, and the Russian Federation.
And we need to explore that, because most people think that the radioactive dating is such a precise science that it's proven the Earth is old.
And they largely be right about that. Let's not forget that Snelling was part of the RATE team. The word rate here is a rather sloppy shorthand for radioisotopes and the age of the Earth. It was a group of young Earth creationists who spent years compiling studies and data in an attempt to show that radiometric dating wasn't a reliable way to establish the age of the Earth. Their final conclusion was that science supported the conventional use of radiometric dating and that they would need miracles to accelerate the nuclear decay and to remove all the heat generated by not just the nuclear decay, but all the other heat-producing processes. That if all happening in the span of a year on Earth would cause the Earth to heat to the point of basically just being a new sun. Snelling's own conclusion was that the young Earth was physically impossible. But that's okay, because he's happy to invoke magic. I don't think I need to tell you why that's not science.
Many theologians, for example, have capitulated to the geologists because they think these numbers on rocks must be absolute, and therefore they have to somehow fit it into the Bible.
Well, they are indeed absolute, even if they're wrong. In the case of dating, absolute dating is dating which gives you a number and a unit of time when asking how old something is. This is contrasted with relative dating, like stratigraphic dating, which simply tells you that a thing is younger than some things and older than others, but can't on its own tell you how old it is in terms of a number of units of time. So for example, radiometric dating can tell you that a particular stratum of, say, rhyolite is 340 million years old, whereas stratigraphic dating could tell you where in the geologic column it should go, but it can't on its own arrive at that 340 million year age. This remains true even if the numbers from radiometric dating are inaccurate.
Well, let's look at these methods.
Hold on to your butts.
And I hope to make this as simple as possible for you.
Probably because if he gets his audience to think too much, they might realize how dumb this all is. We can't have that.
So some atoms of some elements are radioactive. For example, carbon-14 and uranium-238.
That's true.
You know, don't be worried about those numbers. 14 is the size of the nucleus of the carbon atom. It's so large that it's unstable.
No, it's not nearly that simple. Carbon-14, as the name means, has 14 nucleons. That's protons and neutrons. Carbon is the element with 6 protons, so it has 6 protons and 8 neutrons. By contrast, the much larger lead-208 has 81 protons and 126 neutrons, and it is not radioactive. It is instead stable. Nuclear stability is a function of both proton and neutron count relative to each other. You cannot determine whether a nucleus will be radioactive simply based on the number of nucleons it is made up of. For example, radium-208 has the same number of nucleons as lead-208, and it is very radioactive, with a half-life of only 1.3 seconds.
And it decays back to nitrogen-14. Well, uranium-238 is an even larger nucleus, and it decays as well.
Yeah, to the stable lead-206, which is way larger than carbon-14, which means that when he simply says that the stability of a nucleus is simply a function of the size of the nucleus, that he's lying. Because he's already stated that lead-206 is the final decay product of uranium-238 earlier in this very talk.
It has too many particles in its nucleus, in their nuclei, and so they throw those out.
At the level of uranium-238, it may well be reasonable to use nucleus size as a proxy for radioactivity, since lead-208 is the heaviest known stable nucleus. But again, that is not simply a rule that you can use, that the bigger the nucleus, the more radioactive, at least not until you get to 209 nucleons.
And the stable, so they want to become stable again.
Well, let's remember that he just personified atomic nuclei, so if he ever complains about scientists personifying anything else, we can just throw that hypocrisy back at him. But yes, unstable things by their very nature fall apart until they reach a stable state. That's what it is to be unstable in this context.
And it takes a little bit of time for that to happen in the case of uranium, well, today, and that process is known as radioactive decay.
More specifically, it's spontaneous radioactive decay, and that's an important thing to note. There are also instances of induced decay, such as induced fission or beta capture, in which particles actually hit the nucleus, causing it to be more unstable than normal, resulting in a decay that is not simply the result of a nucleus's internal instability, but is instead caused by some definite event. The distinction is important because induced nuclear reactions are heavily influenced by the flux of particles that induce the reaction, but spontaneous nuclear decay is essentially impossible to affect. The rates are based on fundamental constants of the universe, which also govern many other aspects of our reality. To change the timing of spontaneous nuclear decay, it would require fundamental changes in physics, changes that would most likely result in a universe that cannot sustain life and chemistry as we know it. Accelerating spontaneous nuclear decay would require the decrease of the strength of the strong and/or weak nuclear forces. This would not only accelerate decay, but it would mean that nuclei that are actually stable would be unstable, and this would show up as an anomaly in the isotopic ratios when they're tested for rocks formed during this acceleration event. We don't see such an anomaly, and so there is no reason to think that the nuclear forces have ever changed in their strength. That kind of change in one or more fundamental forces of the universe would itself be a miracle. But to get around this, you could simply posit that each nuclear decay was itself an individual miracle, resulting in accelerated decay. But at this point where you're stacking trillions upon trillions of miracles, you have to stop and ask yourself whether or not you actually care about being scientific, if you're willing to hand-wave away anything with increasing numbers of unevidenced miracles that aren't even mentioned in the book that is the primary reason you're even bothering to try in the first place.
The decaying atoms are called radioactive isotopes, or radioisotopes for short, and they produce elements of stable atoms. So potassium, for example, decays to argon.
Well, yes, but it's not that simple. For example, potassium-40 will decay into both argon-40 and calcium-40. Most uranium isotopes end up as lead, but they go through many steps to get there. These steps are part of what is called a decay chain, and you can check to see for the evidence of the decay chain in the rock. You can look for things like decay halos in thin sections of the rock, and since each kind of nuclear decay from each nuclide has a specific energy, you can tell which halos were produced by which nuclides. This is one of the ways to check if the daughter products present in the rock are actually from internal decay, or have contaminated the rock by entering from the outside.
Rubidium decays to strontium, uranium decays to lead.
And before uranium gets to lead, it will also go through thorium, palladium, back to uranium, then back to thorium, then to radium, then to radon. Then it has multiple ways to decay into various elements like polonium, bismuth, astatine, thallium, and mercury, all before getting to lead.
And we'll come to these in a minute. But for the way of illustration, the decaying atoms are called parent atoms.
Usually it's parent isotopes, but whatever, I'm not going to harp on about that.
And the stable atoms that they decay to are called daughter atoms. They give birth to stable daughters.
They're also called decay products. I'm not correcting them here, just adding more information.
And here's the ones that we're familiar with. Parent atom carbon-14 decays back to nitrogen-14. Uranium-238 decays to lead-206. Uranium-235 to lead-207. By the way, you've probably heard of uranium and potassium. You might not have heard of rubidium so much. But what about samarium that decays to neodymium?
I have heard of them all, but then I'm not his target audience. But also saying that potassium-40 decays to argon-40 is not quite wrong, but it's simplified to the point of absurdity. Only about 11% of potassium-40 will decay into argon-40. The other 89% or so will decay into calcium-40. The rest of the chart is accurate, though. The reason we tend to check the argon is that unlike calcium, which is highly chemically active, argon is chemically inert, which means if you find it inside a crystal, you know it wasn't there when the crystal formed because noble gases are generally excluded from crystal formation, which means that while the ratio isn't as simple as in most radiometric dating between parent and daughter, it's more reliable than using calcium-40, much of which may have been primordially present in the rock in question.
You may not realise that you need some of those rare metals for these.
Is it me, or does it seem like Andy has absolutely no regard for the intelligence of his audience? It's a common thing I see among young Earth creationist speakers. They seem to assume that their audience is dumber than a sack of rocks. I find it rather insulting on their behalf. Creationist laity are not generally stupid in my experience. They're biased, misinformed, and willing to use motivated reasoning in many cases. But that's not the same thing as being stupid.
Samarium and neodymium are rare earth metals, and neodymium is critical for those wind farms because neodymium put into the magnet makes it stronger and therefore more efficient in generating electricity.
Yep, I myself have bought many a neodymium magnet because they're the strongest magnets you can really buy for their size, and they're great for magnetizing things like models so you can swap out parts.
And so you hear people talk about critical metals that China, for example, controls the world's supply.
China.
Well, that's why we've been scrambling here in the US and Australia and elsewhere to find resources so that we don't have to depend on China. And neodymium is one of those elements.
Ah, yes. I always wanted more geopolitics in my science lecture about the age of the Earth. Wouldn't it be great if Andy actually got to the point?
Well, what happens? It's quite simple, really. A rock we go out and collect a sample of a rock, and it's chemically tested, send it to a laboratory, and they measure how many parent and daughter atoms are in the rock.
Nope, because chemical tests can't differentiate between different isotopes of the same element. Chemistry depends on the electrons surrounding the nucleus of an atom or ion. Two isotopes of the same element, by definition, have the same number of protons, and so the same number of electrons. As a result, all isotopes of the same element will undergo the same chemistry. The tests are generally mass spectrometry, which tells you which isotopes of which elements are in a sample, but can't actually tell you what chemicals there are because the process breaks chemical bonds. This distinction is important because if you do a chemical test, you can't tell the difference between, say, uranium-235 and 238, or between lead-208 and 207. Uranium-235 has a half-life of 700 million years, whereas 238 has a half-life of 4.5 billion years. That's a huge difference, and conflating the two with a chemical test will leave you in the dark as to the age of the rock.
So, if we know the radioactive decay rate, and it's remained constant at today's measured rate,
and for it not to have remained constant is physically impossible, let's remember.
Then we can calculate how long ago all the daughter was originally parent.
Yep.
And that's the rate rocks say. Let me explain it this way. You're probably glazing over here, but...
Nope, that was about as basic an overview as I could reasonably expect, even if it was wrong in some of the details. And even if it did seem to constantly imply that we might want to take into account the possibility that the fundamental forces of the universe just sometimes have an oopsie.
Think about an egg timer or an hourglass clock. Okay, 2 glass bowls with sand grains. You put all the sand grains in the top glass bowl, and it's supposed to take an hour for all the sand grains to fall to the bottom.
This is a poor analogy for a few reasons, one of which is the decay chains I already mentioned. You see, in all cases the sand falls directly from the top to the bottom, but in nuclear decay, most parent elements go through multiple decay product stages before finally hitting the stable isotope. We can check to see if this happened. Further, in most cases we have numerous isotopes that all start decaying when the rock formed. So the analogy really should have 3 to 5 hourglasses, all of different sizes and different neck widths, all of which can be cross-checked to see if their ratios of sand at the top and sand at the bottom are all consistent with a single time of when all of them were flipped.
Okay, I'm using this analogy. It's pretty good analogy, really, when you think about it.
No.
The more you think about it, the worse it gets, near as I can tell. But I guess I can see why Andy wouldn't want to say that to his audience.
Because I've put red sand grains at the top and green sand grains at the bottom.
That's just weird. The sand in the hourglass is all the same sand. Why do we need to add this extra and impossible step to the analogy? I can't see why, but sure, whatever.
The red sand grains are the parent atoms, and the green sand grains are the daughter atoms, okay?
Sure, it's needlessly dumb, but whatever. Maybe there's some kind of magical field in the neck of the hourglass that changes the color of the sand. I don't care.
And so let's imagine we're cooking a cake.
I'm going to pretend it's a pie, because I prefer pie. Also, cheesecake is actually a pie because it has a crust and a filling. For me, a cake has to be made of batter or dough the whole way through, not just at the bottom.
Okay, and you in your kitchen and you mix up, by the way.
No, by the way, he's just going to tell a story about a time he assumed that everyone preparing a meal in a church kitchen was a woman, and he was corrected. It's neither surprising nor relevant that Andy is a sexist.
And you put the the mixture in your cake pan to bake it, and you put it in the oven. Well, you want to time how long it's in the oven, so you use an hourglass clock.
No, I tend to use the microwave or my phone's clock app, but whatever. Let's pretend this is like the 1920s and I'm using sand to time my baking.
So you start by putting all the sand grains in the top.
No, I don't. Has he ever used an hourglass? They're generally sealed. You don't put the sand anywhere. After it has run out and all the sand is at the bottom, you just flip it over. I think Andy here just does not understand how hourglasses work, which might be why he thinks you can have red sand at the top and green sand at the bottom, even though that's not how they work.
You walk out of the kitchen, maybe you've got to go to the garage and you've got to do something, or the laundry, and you come back and you want to know how long you've been away. Well, what do? You look at that hourglass clock and you measure, visually, you decide how many sand grains are still at the top and how many are at the bottom. So that's what a geologist does. He gets a rock and he finds out how many parent and how many daughter atoms are in the rock.
Yeah, this part of the analogy is okay. Let's see how he screws it up. Of course, one group of people unlikely to screw up analogies are my subscribers, because they get to hear my amazingly awesome analogies when I make new videos. So take a minute to check to see if you're subscribed, and if you're not, why not go ahead and fix that, and also turn on notifications so that the subscription actually means something to YouTube.
Well, what if you find that half the sand grains are still at the top and half are down the bottom? How long have you been out of the room?
All things being equal, and assuming a linear flow rate, about half an hour.
Half an hour, okay?
Okay.
Because you know the rate at which the sand grains fall, because you already tested it. You know, you've used a mechanical watch like this, and you've watched all the sand grain. You know it takes an hour, so you've accurately measured your clock.
Well, I probably relied on people who made the thing to tell me how long it runs for, but whatever. Where's the but that we all know is coming?
Clock. So that's as simple as it gets. The geologist finds out how many parent and daughter atoms there are, and then he works out how long ago all the green atoms, the daughters, were originally parent. Okay, because he knows how long it takes for it to fall, to decay, okay? And therefore, you back calculate, and that's the age of the rock. That's how long ago the rock formed. Okay, I haven't lost too many of you already?
I'm certainly keeping up, and I suspect my audience is as well. Because unlike creationists, I don't think my audience is a gaggle of gibbering morons who can't tie their shoes without explicit instructions and diagrams.
Now, it's quite simple, therefore. So starting with all the sand grains in the top bowl, it takes 1 hour for all the red sand grains to fall to the bottom as green sand atoms. So a rock is chemically tested for these red and green atoms.
Again, they're not actually red and green, just FYI.
And we make assumptions. And that's the important thing. You know, whenever you see the scientists make a statement about things that happened in the past, you should immediately ask the question, what are they assuming? What are their assumptions?
A big one is that the weak nuclear force did not change in the past, which isn't just an assumption, it's also testable, and we see no evidence of it having varied. So like most so-called assumptions in science, it's actually just accepting science that has already been well demonstrated and moving on, all while having the ability to check if this conclusion about prior scientific work is actually valid.
Because the assumptions are critical. If you start with the wrong assumptions...
Like, for example, the assumption that Iron Age literature should be the thing that you check your science against, and that rejecting reality is a good thing when reality and the Iron Age text disagree according to your interpretation.
You're going to get the wrong answer.
Like that Earth is only 1/750,000th of its real age?
It's just like I said this morning.
I wasn't around for that, so I have no idea what was said that morning.
The master of the feast assumed that the grapes had grown on vines and been harvested, and the wine had come by a process when Jesus had actually created. He had the wrong assumptions.
Okay, cool, but what does this have to do with anything? If a miracle occurred, then yeah, science is going to have trouble with that one. But that's because such things are physically impossible and largely outside the scope of science. This talk is called Science Confirms a Young Earth, so appealing to miracles is just an admission that science in fact does no such thing. Because if it did, you wouldn't need to appeal to miracles.
Okay, so if the rate of radioactive decay has remained, that is falling at today's constant rate, it can be calculated how long it took the measured amount of green atoms to accumulate from the red atoms to fall.
I feel like that sentence could have used a few more editing passes.
And so you know how long it's been operating, the hourglass clock, which is the rock's age. So I said, though, that you've got to have assumptions. And there's three crucial ones.
Ooh, are we finally getting to the actual point? That sure would be nice.
And they're even more crucial when it comes to these dating methods, okay? Remember our analogy?
Get on with it. Yes, get on with it.
Get on with it!
Three crucial assumptions, okay. What would happen if all the sand grains at the bottom hadn't come from the red sand grains at the top?
Then I wouldn't have used the hourglass because it would have been lying on its side, which doesn't really correspond to anything in this analogy. But remember, because we actually have numerous options for radiometric dating corresponding to multiple hourglasses of various sizes, we can check for this. If one of our dating methods is significantly off, it may well be because of initial daughter products, and we can cross-check to confirm this. For example, say I had 4 hourglasses of all different sizes, and 3 of them indicated that they were flipped over a half an hour ago, but one indicated that it was flipped over 45 minutes ago. Chances are that there's something off about that one. Maybe it wasn't completely empty at the top when it was turned over. Maybe the stated duration on it is wrong, etc. This is what isochron dating is for. All the relevant isotopes are checked for multiple dating techniques, and the ratios and dates those ratios give are checked. In this way, we can avoid being wrong because some rock just happened to form with a bit extra lead or something. But further, some decay products such as argon are chemically excluded from the crystals forming in rocks because they do not undergo chemical reactions, which means that it's pretty much impossible for them to be primordial.
What if you didn't know the initial, you weren't there at the beginning, and maybe there were some green atoms already in the hourglass clock at the bottom when your clock started?
Isn't that exactly what we just went over? Am I missing something new? I don't know, let me know in the comments what you think.
If you weren't there at the beginning, you see, the geologists weren't there millions of years ago when the rock formed, so how do they know the original amounts of parent and daughter atoms?
By adding the two up and checking for contamination by things like isochron dating and checking for metamorphosis or water leaching into the rock. I know that sounds like a really simple answer, but that's because it kind of is. This is actually a pretty basic aspect of radiometric dating. You check to see if the requirements for the technique to work are met by the sample being submitted. And if they're not, then you know you can't rely on the date. But if they are, then you can. And again, we know we can rely on it because a $1 trillion industry relies heavily on it working. Trust me, oil companies do not give a f about proving the Earth to be old, getting people away from Christ, or anything like that. They just care about dollar signs, and radiometric dating gives them money.
Why would there not be daughter atoms in some of these rocks?
Because some daughter nuclei would be chemically excluded, and also in some cases there might be. That's why you check.
Why would the Earth give you the same age as meteorites?
Because they formed at about the same time within probably a few score million years, which at ages like 4.5 billion is basically simultaneous.
Well, because God made the meteorites of the same stuff as the Earth.
I mean, sure, if you want to say that God is the ultimate cause of the universe and therefore is the creator of the solar system and the nebula from which it collapsed, I won't stop you. I am not here to get people to stop believing in God. I am happy for people to believe in God or not, at least as far as this channel is concerned. In private, I have my own beliefs, lacks of belief, and opinions, but they don't matter to the science, so I don't talk about them.
The meteorites come from asteroids, and some of these asteroids have a core and a mantle and a crust exactly like the Earth.
Not really. Except for the largest ones like Ceres, most asteroids are far too small to have had much density sorting due to gravity before they cooled. This can be seen in the fact that they didn't even have time to reach hydrostatic equilibrium, that is, become more or less a sphere. As a result, asteroids are much more homogeneous than, say, the Earth is. But then again, it's not like there was no density sorting at all, so he's not completely wrong.
Well, obviously, God used the same design and used the same stuff to make all these different things.
But that's not obvious, that's not in the Bible, and there's no particular reason God had to make the Earth out of mostly iron and silicon, and couldn't have made asteroids out of mostly lead and tungsten. The only reason Andy thinks this is the case is because he started with the assumption that the solar system was specially created at some point, and then on finding that asteroids and the Earth have the same basic elemental composition, came to the conclusion that God just did it that way. This wasn't a prediction of creationism. It wasn't even a retrodiction of creationism. It was an accommodation by creationists to the data.
And God loves variety, so why wouldn't he make the daughter atoms as well as the parent atoms? And the daughter atoms didn't come from radioactive decay at the beginning.
Yeah, why wouldn't God just make everything to look like it wasn't specially created and then tell people it is specially created, just to fool them? I don't know, probably because that makes God an omnipotent trickster and it destroys the ability to have any reason to believe anything. Meaning it requires you to abandon any sense of an epistemic framework and makes knowledge of any kind impossible. Maybe that's why, Andy. Or maybe we can just not let an omnipotent liar into our philosophical framework, and that way we can actually have a philosophical framework rather than just chaos.
You see, if we weren't there at the beginning to know the initial conditions, how can we be sure that our clock works?
By checking. Just like the last time this question was asked. You check other methods, you check other meteorites, you check other rocks, you make predictions, etc. In other words, you do this thing that Andy seems not to understand in the least, called, let me check. Yes, sky ants. Wait, no. Science, yes, that's it. You do science.
And so assumption number one is there are no green atoms at the bottom of the glass bowl at the beginning.
That's less an assumption and more like a prerequisite, and is something that you can check on. And in some cases, it isn't actually a problem at all because chemistry was a thing in the past and continues to be a thing in the present, and I expect will continue to be a thing in the future.
And I'm going to give you some examples where these assumptions are shown to fail from the very literature that the scientists refer to.
Thereby showing that scientists are aware of the limits of their techniques and so know when not to use them. That's an interesting tactic.
In every case, you need an observer because we weren't there in the past. So assumption number two is that all the daughter atoms measured today must have only come from radioactive decay in situ of the parent atoms. In other words, the glass bowls were a closed system.
Well, in the case of hourglasses, they're generally sealed, so you can check to see if they've been tampered with. In the case of rocks, you can also check. Most processes that would allow significant amounts of any chemical into or out of a rock involve processes that are evident in the rock itself, such as metamorphism, which is just what happens when rocks are under lots of heat and or pressure for a long time. We've already mentioned a gneiss in Canada, and gneiss is a metamorphic rock, meaning that you have to be careful when radiometrically dating it. But again, we can check to see if there are discordant dates among multiple dating techniques, and use that to test this particular condition of the technique.
Well, when you're out of the room, you didn't know that your mischievous 10-year-old son came in and lifted the lid and put a few more red sand grains at the top.
Has this man never even seen an hourglass? They don't normally just have easily accessible lids specifically because the exact amount of sand in them is important and has been calibrated to keep the accuracy of the hourglass. You can't just normally open them up, stealthily add some sand, and then seal it back up. And for the very same reasons, the same is generally true of rocks. They can gain and lose things, but it's not common, and you can generally tell if there's reason to suspect that this has happened.
So that when you came in and did the measurement, you thought you'd been out half an hour, but actually it'd been longer. Because the system was contaminated, it was open.
And this is why hourglasses are kind of a stupid way to do this analogy. Water clocks would have been better, since those are generally open to the air, but then again, I don't know if people know what water clocks are. I mean, they're basically the same concept as an hourglass, but with water in open containers rather than sand in a closed glass bulb, but oh well.
That's the second assumption. All the green atoms must have only come from the falling of the red atoms. That is, there's been no contamination.
Good thing we can check to see if that assumption is satisfied, and let's remember, fundamentally, when dollars are on the line, radiometric dating works. And unlike many other modern dating techniques, you're not going to get catfished when you do radiometric dating.
And that requires an observer. Have the geologists been there for millions of years to watch these rocks not having been contaminated? No.
So what? Was anyone sitting in Andy's mom's uterus to watch him be conceived? No. And yet I bet very few people would dispute that it happened for that reason. Turns out that sometimes the present shows us things about the past because things like the laws of nature, time, and causality are things that exist. Indeed, even the idea of wanting a witness to an event is based on the idea that these things exist, because otherwise, how could an eyewitness be reliable? It's almost like demanding an intelligent witness to an event to accept that event as having occurred is a self-defeating standard of evidence, and not one that even young Earth creationists consistently use. Creationists generally have no problems with things like forensic science being used to solve crimes when there are no eyewitnesses to the crime, or at least none who will testify. But this is just rank hypocrisy on their part. Either empirical data gathered in the present can give us information about the past, or it can't. Andy wants to have it both ways for some reason. I mean, I know the reason. It's because he needs to be able to have double standards so he can reject the science he doesn't like while accepting the science he does like, even though there's no evidentiary or philosophical justification for it.
By the way, most of the samples they collect to date are collected at the surface of the Earth.
In a shocking twist, most geologists are not mole people.
Now, I can take you down a mine shaft.
Pass. I do not want to go anywhere where Andrew Snelling is in any way part of keeping me safe.
Down half a mile or more, and the rocks down there I can show you, still show the effects of weathering.
I mean, yeah, rocks under the ground used to be on the surface, unless they're intrusive, which most of them are not. This shouldn't be surprising, but it's also why samples are often taken by drilling into a rock, not just crushing up the whole thing, surface included.
Weathering contaminates rocks.
Yeah, at the surface, but if you have a bunch of basalt being worn down by wind and rain, and then you clean that in a lab, break it in half, and get a sample from the middle, you don't really have to worry much about surface contamination. This isn't really that complicated, nor is it news to actual scientists.
Most people don't realise that some of the uranium deposits form as a result of weathering of background amounts of uranium that's concentrated by water carrying it in solution, and then it's deposited in a concentrated manner. And that's why it becomes economic to mine it.
Yep, I'm sure lots of people don't realize that. But you know what geologists realize? That you can't really radiometrically date sedimentary rocks. So who cares if the best concentrations of uranium are in waterborne sedimentary rocks? Those aren't the rocks being radiometrically tested. It's also not an example of the contamination of an igneous rock that would affect the dating. Unless he really wants to say that the weathering is pulling the uranium from the middle of the parent rock. If he doesn't want to say that, I would be fascinated to know what mechanism he proposes for this.
So we know that contamination is a problem, and I'll give you some examples in a minute.
I look forward to it.
And then the obvious third assumption is that the rate of radioactive decay has been constant at today's measured rate.
In other words, one of the assumptions is that the fundamental forces of the universe that govern physical interactions between particles of matter and force carriers, etc., are what they are, and were what they are. This is just the basic assumption of science, that the universe fundamentally operated according to the same rules in the past that it does now, and that it will still operate by them in the future. That's what allows predictions of future data in science, both about events in the past and in the future. Without this assumption, nothing in science can be made. You'd be stuck in the world of Al-Ghazali's Incoherence of the Philosophers, where there is no such thing as a natural world that operates under consistent principles, and instead every single effect is a direct miracle by God. And if you think causality is a thing, then it's just because God wants to be consistent today. But he doesn't have to be. The publication and popularity of that book, by the way, is around the time that the Islamic world started to slide away from being on the cutting edge of science, and entered a long slide into backwardness and lack of scientific progress that still plagues many Muslim-majority places today. There's a reason no one is rushing to Saudi Arabia to get their degrees. The rejection of the temporal invariance of the nature of reality is devastating to any scientific progress, and should be rejected simply on the ground that it makes any study of the natural world fundamentally impossible. I also want to note that I am in no way saying that Muslim scientists don't exist or don't do good work. They absolutely do. But it's hard to argue that the popularity in majority Muslim regions of a philosophy completely antithetical to science didn't hinder the ability of those areas to produce scientists. I also want to point out that this philosophy of radical occasionalism is not universal in Islam, and it never has been. Many famous Muslim scholars like Ibn Sina, or as he's often known in Western circles, Avicenna, have a very scientific outlook and made great strides that moved forward human knowledge in important ways. So I guess in conclusion, being an Ibn Sina, not an Al-Ghazali, and Andy is being an Al-Ghazali.
That means the red atoms have always fallen at the same rate to produce the green atoms as we measure them. And that requires an observer as well. Have the geologists been there for millions of years to check that radioactive decay has been constant?
No, nor do they need to be. Because remember, the only way to vary this, short of rejecting literally all of science, is to say that the fundamental forces of the universe changed. But that would not only change the rate of spontaneous nuclear decay, but also which nuclides are radioactive in the first place, which means we would see evidence of decay chains that no longer occur. We see no such evidence, hence the nuclear forces have not meaningfully varied during the history of the Earth. In fact, the Oklo natural reactor is a great example of this that even uses some induced decay in the form of induced nuclear fission. But the important thing is that after the fission, the resulting nuclides decay spontaneously in ways that are both predictable and traceable into the past, simply based on what's found in the rock. The rocks in the reactor, which is in Gabon by the way, show the telltale ratios of being the result of induced fission of uranium-235, which corresponds to the also noticeably depleted amount of that isotope compared to the normal ratios on Earth. If the rate of decay had changed in the past, then this would not be the case, yet it is. Hence, the Oklo reactor is yet further evidence that no, physics didn't just pull a fast one on us a few thousand years ago.
Yes, as I say, what if your mischievous 10-year-old also put in a few drops of water into the glass bowl? What's that going to do?
Well, apparently, since these glass bowls are just open to the air, probably evaporate and cause no noticeable effect. But really, the analogy is closer to if your kids scratch the outside of the hourglass. What's that going to do? The answer is nothing that really matters.
It's going to clog it so that the falling rate slows down.
Not in his stupid scenario of open hourglasses, but whatever. This doesn't at all map onto nuclear decay because there's nothing you could add to a rock that will accelerate the rate of spontaneous decay. Because nothing you add will affect the nucleus, short of adding more radiation to induce nuclear reactions. But induced nuclear reactions do not follow the same decay chains as spontaneous ones. So we can also tell if that happened, which is how scientists know that Oklo was a fission reactor.
How do we know that the decay rate has not been constant?
We don't know that. In fact, we have overwhelming evidence that it has been constant, and nothing to even hint that it could be otherwise.
Or has been constant in the past?
Physics.
So, assumption one, number one, all the parent atoms, daughter atoms derive from parent atoms, no initial inheritance.
Which can be verified in most cases.
Assumption number two, no other processes have affected the parent-daughter relationship, so there can't be contamination.
Which can be verified in most cases.
And three, constant decay rates, no changed rates.
Which is fundamentally just the assumption that science works. Given that he's using a microphone and was live streamed to a website via a camera, all of which depend on engineering based on physics, which is part of science, I'm going to go out on a limb and say that yes, in fact, science does work.
Well, it should be obvious that none of these assumptions are provable.
In the mathematical sense, that's true, but then that's true about all of science. But since two of them can be verified, and one is just that science works in the first place, I think they're fine despite the fact that they're not mathematical theorems.
The past cannot be observed and measured and tested.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
And these assumptions are not even reasonable.
I'd love to hear why not, especially since they can be tested.
Because we know that these three assumptions have been repeatedly falsified.
I don't know that, and I suspect that neither does Andy. But I do look forward to seeing his evidence for this, which definitely won't be cherry-picked, lied about, or in any way full of Trojan sources.
And I'm going to show you that tonight. They're falsified.
Well, we'll have to leave this attempt to show that for the next time. This video is already long enough. We'll continue on with these sources that definitely say what Snelling needs them to, and definitely won't be taken out of context next time.
Daughter atoms are known to have been inherited when rocks form, but even when not detected, it doesn't mean there isn't any contamination. I can show you examples where the geologists thought they had a perfect result, and yet the sample later, they showed that the samples were contaminated.
Well, this isn't a source at all, and of course, sometimes bad measurements come in. That happens with every measurement technique. Is the fact that I've measured a piece of wood incorrectly and then had to go get a new one when I cut it too short evidence that tape measures don't work? No, of course not. The fact is that occasionally, with any measurement, sometimes you get a bad result. But the fact that geologists can actually tell this is a good indication that when measurements are scrutinized and there is no contamination, that makes the measurement reliable. And that's the vast majority of measurements, and it's why there are techniques such as isochron dating to help find these problems.
And assumption number one, the inheritance, is often violated. And so,
as Andy has already admitted, scientists can tell, and so while this is a limit to the usefulness of the technique, it is not something that invalidates the technique overall. Just like the fact that sometimes people can't tell if the dress is blue and black or white and gold doesn't invalidate eyes as useful for gathering information about the real world.
contamination is common, and it's often, that assumption is often violated. So,
common and often. Those are fun weasel words right there. Snelling gets to toss that out there, and people think that he must mean like 60% of radiometric dates are tossed due to contamination. Which, even if it's true, doesn't invalidate the other ones. But how often is contamination actually a problem in radiometric dating? Is it 90%, 45%, 20%, 10%, 1%, 0.1%? I don't actually know. Near as I can tell, no one has bothered to do a study about it, which isn't very surprising. How many people do studies on how often a measurement is made in error of any kind? In fact, the only people who seem to indicate that it's common are all the creationists. Pretty much everything real scientists write about it is just how to mitigate or prevent contamination.
several lines of evidence have also demonstrated conclusively that decay rates were grossly accelerated during a recent past catastrophic event.
So this is accelerated nuclear decay. It's the idea that in the past, in violation of the laws of physics, the rates of all spontaneous nuclear processes were sped up by some 9 orders of magnitude or something. And all of them by the same factor, all without actually making any previously stable nuclides unstable, meaning it couldn't just be a lowering of the strength of the nuclear forces. Of course, what lines of evidence indicate that this is a real thing that happened? None. It's just necessary for young Earth creationism to be true, because the rate team concluded that, indeed, there was 4 billion or so years of radioactive decay evident in the rocks of the Earth. The entire idea of accelerated decay just boils down to question begging.
Do you know of a recent past catastrophic event?
Is it the flood of Noah, which also has no evidence and would violate several other laws of physics?
The flood.
Oh gee, you don't say. How surprising.
Geological processes were accelerated at rates we can't even imagine.
We can't imagine them because they're literally impossible. There is physically no way to use a global flood to explain the geology of the Earth. The flood can't lay down windborne sediment, yet we see them. The flood can't deposit evaporite deposits, yet we see them. The flood can't lay down fine silt or lime, yet we see strata made of them. The flood can't do anything but lay down a bunch of graded sediment, and that's just not a good description of the geology of the Earth.
You know, some people say to me, how can all those layers have formed during the flood?
That's a good question, since floods lay down sediment in order of size and buoyancy, which is absolutely not how the sediment on Earth is deposited. For example, a flood couldn't lay down sandstone on top of shale, and yet we get layers on Earth with no hydrological consistency. Limestone can sit on top of sandstone, which can be above graded conglomerate, which is above shale.
We can't even devise an experiment to replicate that.
I mean, it's called a sedimentation tank. Sure, you'd have to do scale experiments, but they could actually at least provide plausible deposition methods. But one of the things creationists really hate doing is testing their ideas. And that's why they never really do anything but half-assed morphological studies to pretend their idea of kinds means anything. That's why instead of building a big sedimentation tank, they built a giant building in the shape of a boat that never existed. That's why rather than actually figuring out the physics of accelerated nuclear decay, they just lie about human-chimp genetic similarity.
And so we can't understand how catastrophic the rates were to generate all the layers that we have and buried all those creatures to make the fossils, and it all happened in about a year.
No, we don't have to comprehend it. No one comprehends particle physics, not really. But the math is doable, and it is done, and it is used to produce things like ever smaller transistors, nuclear power plants, and even weapons. It doesn't matter if the numbers involved in the flood are ones that can be intuitively comprehended by human minds. It just matters that the physics work. And in this case, the physics does not work.
Well, if all these other geological processes were accelerated during the flood...
Which, let's be clear, there were not in any way, because that's physically impossible, and only believe because otherwise the flood isn't true. You know what normal people do when they realize that what they think can't possibly have happened? They stop believing the thing happened. What creationists have a tendency to do is just double down and assert even more things that physically could not happen.
Then why not radioactive decay?
I mean, yeah, why not? If you're already going to believe that a flood with an impossible amount of water that impossibly didn't produce enough heat covered the Earth an impossibly short amount of time ago, laying down layers of sediment it couldn't possibly have laid down actually happened, why not add in one more impossibility? In the words of Lewis Carroll's Queen of Hearts, why sometimes I've believed as many as 6 impossible things before breakfast.
And so we can demonstrate that the assumption no change rates is also violated.
Ooh, I look forward to the source on this. Surely it won't just be complaining that if the rates hadn't changed, then the Earth couldn't be young, because that's all the evidence for this that I've ever seen.
By evidence of accelerated radioactive decay. Now,
yeah, great. Where's the evidence?
Before I give you the examples here, I want you to understand that I'm not questioning the quality of the chemical analyses.
I couldn't possibly care less.
When we send a rock to a lab, the chemists do a brilliant job in doing their analyses. I can send several pieces, I can break a rock up, sample up into several pieces, and I can send the several pieces to different laboratories, and I guarantee I'll get the same result.
Cool. Let's see the evidence.
They spend millions of dollars building these laboratories.
Get on with it. Yes, get on with it.
Get on with it!
And so they do excellent chemical work. But you get a chemical analysis, and that chemical analysis has to be interpreted using those 3 assumptions.
Again, it's usually an isotopic mass spectrometry analysis, not just a chemical analysis. That won't help. I went over it in the last video, but in brief, because isotopes of an element are differentiated by neutron numbers, the electron orbital shells of 2 nuclides of the same element will have the same chemical properties, and so chemical tests on their own cannot distinguish between different isotopes. Some other tests can be performed, such as density tests to differentiate regular water from heavy water, in which the hydrogen-1 or protium is replaced with hydrogen-2 or deuterium, but you're going to have trouble just weighing a rock to figure out the isotopic ratios.
So it's not the analyses that's disputed, it's the interpretation of the millions of years ages because of these 3 unprovable, repeatedly falsified assumptions.
I see Andy is taking leaf out of the alleged book of Joseph Goebbels. If you tell a lie big enough and keep repeating it, people will eventually come to believe it. Now, I know that there's no actual evidence Goebbels said or wrote that. Still, though, it certainly seems to be Andy's strategy.
So, my first example, let's go to Mount St. Helens. Back in I've almost forgotten it was. 1980, it blew its top. And the top part of the mountain was blown off, and a new lava dome formed in the crater. And the geologists watched, and they could see the lava flows building that crater, and they knew the exact day when all these layers were formed. And so it was very easy to go in and get samples there. My colleague Steve Austin.
Steve Austin, astronaut, a man barely alive. Gentlemen, we can rebuild him. We have the technology. We have the capability to make the world's first bionic man. Steve Austin will be that man.
Went in and got samples, and here we see the 1986 dacite lava flow. It was about October 1986, in fact. And so he sent that sample to a laboratory for analysis. He didn't tell them where it came from.
Which, you're required to normally.
And he sent it to them in 1996, so he knew that the rock was only 10 years old because we'd watched it formed.
The them in this case is Geochron Laboratories, a now defunct radiometric dating lab in the Commonwealth of Massachusetts. They themselves had a public warning that their potassium-argon machines could not date rock below about 2 million years of age, and that any dates below that value were more or less meaningless. This is because of the machines that they used. As I've already said a few times, radiometric dating uses mass spectrometry. In this technique, a sample is vaporized in a vacuum chamber. After the test is done, the vacuum chamber is evacuated by pumps. But the thing is that no pump can create a perfect vacuum, and the testing machines at the Geochron Laboratories were known to only be able to pump down so much. The problem being that if you're testing very young rocks, then the argon that's still in the test chamber from previous tests that has not been evacuated from the chamber may result in erroneously old ages. Now, in older samples that have larger internal amounts of argon, this is not as much of a problem, since the amount of argon still in the test chamber will be negligible compared to the argon in the sample. This is not the case for very young samples, where the argon in the test chamber may be even more than is in the sample, completely swamping the results. Essentially, below 2 million radiometric years, the machines are just too noisy and will not return meaningful results.
Okay, what results did he get? Well, the whole rock sample gave an age of 0.35 million years.
So since that's lower than 2 million years, that means that the result is completely meaningless. Something known to Austin at that time, unless of course he's just too stupid to read about the lab he's paying to test his samples.
He separated the different minerals, and the different minerals gave different ages as well. In fact, one mineral, pyroxene, gave an age of 2.8 million years.
In fact, that is the only test from this that even gave a date that was barely outside the range of meaningless results. What's the problem with this? Well, simply that included in the pyroxene sample were visible crystals that, from just Austin's own paper, seem to be consistent with what are called xenocrysts. That is, small minerals with high melting temperatures that will often not be melted in a volcano, and which are later incorporated into younger rocks. These minerals are obviously going to be older than the rock in which they're embedded, and they can be billions of years old, although they do not need to be. So what did Austin do to assure the scientific world that the things that sure looked like xenocrysts weren't xenocrysts? He basically said, "Trust me, bro." And here's the thing, when it's your goal to overturn geology, particle physics, relativity, biology, and thermodynamics, "Trust me, bro," doesn't really cut it.
Why?
I mean, if I were a less charitable dinosaur, I'd say because Steve Austin, like Andrew Snelling, is an intellectually dishonest piece of who wants to drag the scientific progress of the human race back a millennium or so and stifle curiosity about the world with adherence to an obviously incorrect dogma that makes him feel better about his own mortality, even though this particular belief isn't necessary to have that feeling. That's what I would say if I wanted to be mean. Instead, I'll just say that it's because Austin ignored basic procedure and then almost certainly included contaminants, perhaps knowingly, in order to produce an erroneous age for rocks. And again, since I'm being nice, I won't say that he was motivated to do this by wanting to encourage anti-science beliefs and attitudes among his co-religionists by pretending to have debunked one of the most well-known and reliable techniques for dating the age of rocks, which devastates his entire view of the history of the universe by simply existing. Since I'm being nice, I'll just say that he must have done it because he's an immense moron who got his PhD as a result of some oversight of the fact that he seems, since I'm assuming no malicious intent, to have the intellectual capacity of a comatose sea sponge. And yes, I'm aware that sea sponges can't really go into a coma.
Well, the answer was already there in the literature. Because you see, what comes out of volcanoes? Gases.
Yeah.
And argon is in the volcanic gases.
Yes, specifically because it tends to come out of magma solutions very rapidly when exposed to lower pressures, because it is a gas and being chemically inert can't really be included within crystal structures, and so primordial argon is mostly absent, which is why potassium-argon dating tends to be so reliable. You know, unless you dishonestly present your samples to a lab that you know full well can't actually date them by your own admission, and you also include, probably knowingly, xenocrysts that contain argon as a result of internal decay from when they formed much longer ago. There are also a few more caveats to potassium-argon dating, but we'll get to those later.
In fact, most of what comes out of a volcano is steam, water in the form of steam. And when some of that argon was actually trapped in the lava when it cooled and crystallized.
That's extraordinarily unlikely, and Austin gave absolutely no evidence for this. It's true that if there were excess argon from argon failing to degas from the lava, that it would result in erroneously high dates, but the results he got were also compatible with there being no excess argon. In fact, the results are compatible with the rocks containing literally no argon at all, except in the xenocrysts, that we have every reason to think were in the pyroxene samples.
So argon was inherited by the rock when it formed. It was argon that hadn't formed from radioactive decay of potassium in situ within the rock.
If only that were a conclusion that could actually be drawn from Austin's, work. I'm sorry, I'm trying to find a polite way to say almost certainly intentional scam study. It's a very hard thing to come up with a good euphemism for.
And so that's why I've got the conclusion here. It was inherited excess argon. And we know that from the literature.
I mean, not from Austin's literature we don't, but I'm going to go ahead and guess that this is the only source we're going to be given to demonstrate excess daughter material being a problem for radiometric dating. A paper that didn't show that at all.
Boy, was I wrong.
If you fly into the big island, into the airport at Kona, just beside the airport, well, on the airport is on a lava flow, and the golf course is right nearby. That was an eruption in 1800 and 1801.
Let me guess, someone else pulled in Austin and used the wrong machines on the wrong rocks to get the wrong age.
And yet it gives ages up, that lava gives ages up to 1.4 to 1.6 billion years.
In the case of the Hualalai basalt, this is not quite what happened. These results are from the 1996 paper by G.B. Dalrymple, author of, among others, the book Ancient Earth, Ancient Skies. In this one, he actually does seem to find excess argon, which it noted is unusual among volcanoes. It is also notable that not nearly all the dates were outside the expected range, and it is also notable the amount of excess argon found at formation would become negligible after enough decay, meaning that this small amount of excess argon resulting from unusually argon-rich magma that cooled very rapidly, limiting outgassing of argon, would only be a problem for the dating of relatively young rocks.
For a recent lava flow, because it inherited the argon.
Yes, unlike in the previous example, this did indeed show anomalously old ages for that reason, but also other reasons. For example, Dalrymple also found xenolith inclusions, and rather than just pretending he didn't, he reported on them, noting that they also contribute to an old age. And of course, this doesn't address the fact that the amount of intrinsic argon was both unusual in these rocks and wouldn't be enough to explain much older dates in other rocks. In these young rocks, intrinsic argon can account for more or less all of the argon, but as time goes on, it will be a smaller and smaller portion of the argon. For example, if we take the 1.4 million year low end for the range of dating, assume that it's going to consistently increase our age estimate by about that much, then after a million years, we would expect the intrinsic argon to be increasing the age of the rock by about 42%, which is pretty significant. But if the rock were, say, 50 million years old, then this excess argon would only increase the age of the rock by about 2%. And if it were, say, 100 million years old, it's not even quite 1%. So if I come to a rock and potassium argon date it and get an age of 200 million years, but Andy shows me this paper, then guess what? He's basically told me that there might be some effect of excess intrinsic argon that can account for an additional error of about half of what I'd ordinarily expect anyway, which is to say that it's about 200 million plus or minus a couple million years. Snelling is complaining that really, if I wasn't taking this into account, I should be reporting 198.5 plus or minus a couple million years. I mean, okay, sure. And you might say, well, wait a minute, how do we know that if it doesn't work on young rocks, that it works on old rocks? The biggest reason is just the amount of argon. These amounts are quite small and below the range of accuracy of some potassium argon testing, meaning they're minuscule. How do you explain much higher concentrations of argon and depleted potassium? The only obvious way is the actual decay of potassium into argon in the rock, and since we don't have an even possible, never mind plausible mechanism for accelerated nuclear decay, then this problem isn't really a problem except for the youngest rocks. Now, assuming that the error introduced by this excess intrinsic argon from incomplete outgassing, which remember is uncommon and remarkable for happening in this basalt in the first place, will simply add 1.4 to 1.6 million years to any reported age is hugely simplified. But it doesn't really matter, because as the rock ages, the amount of new argon will continue to go up, and the proportion of primordial to new argon will continue to get lower and lower, making it a less and less significant source of error as time goes. And when you get back to an age in the hundreds of millions of years, something not at all unusual, incomplete outgassing simply cannot account for it.
And so here's some other examples of that. It's well known in the geological literature. It's been known since the mid-60s.
Yeah, it's been known since the mid-60s that potassium argon dating is more reliable the older the rock is. For very obvious reasons if you stop to think about it. Also, the rest of these examples are all under 400,000 years old. That's within the margin of error for many potassium argon tests, and well under the ability of many laboratories to measure meaningfully in the first place. In fact, these are also from Dalrymple and are further demonstrations of his, from the same paper as the Hualalai basalt, of the pitfalls of improper controls and young rocks. That's the whole point of the paper. His reason for doing this study was to establish what rocks might give erroneous ages and why. Cherry-picking his work on this problem and then presenting it as if it's representative of how radiometric dating is done generally is deeply dishonest. Further, even if this paper did present problems for potassium argon dating as a whole, which it does not, it would simply only be potassium argon, and as is stated by Dalrymple, that's why you do more than one technique and you sample multiple parts of the rock in question. You want to be able to check for problems like the ones he identified.
1960s. That this is a problem with this method, but they keep on using it.
Wow, some people are allergic to drugs like amoxicillin, the most commonly prescribed antibiotic in the US in 2023. Why do we keep using it if there are problems with it? Oh, right, because there's problems with everything. And identifying cases where there is a known problem doesn't mean that all instances of the use of a thing are themselves problematic. There are no perfect measurement techniques, and finding the boundaries of their use is important. But you'll notice that he won't bring up the eruption of Mount Vesuvius, the volcano that destroyed the Roman cities of Pompeii and Herculaneum, which has been radiometrically dated to within the historically reported calendar year of 79 CE. I wonder why that is.
Well, they took 10 diamonds from the Democratic Republic of Congo, and they dated it using potassium argon. They didn't just use one sample, they used a number of samples, and guess what? The diamonds came up with an age of 6 billion years. Well, they knew that was wrong, because how could the diamonds be older than the Earth itself?
Oh, look, guys! Snelling discovered the mantle can't outgas, and so when intrusive igneous rock from the mantle ends up in the crust, it gives an older date than expected. It's almost like this too is a known limit of potassium argon dating. You know, if you want, you can pick out limitations with other measuring mechanisms. Did you know that a spring scale purchased and calibrated in Toronto will give the wrong weights if you just take it to Bogota and use it there? Yeah, it's a result of the lower centrifugal force in Toronto versus Bogota. Does this mean that we need to toss out spring scales? No, that's extremely dumb. I can in fact give you lots more reasons that a spring scale will be wrong. For example, if you use the wrong test weight to calibrate it, it'll give you the wrong weight. If you take it on a plane going mostly east or west, it will also change the reading due to the Sagnac effect. Now, if all I do is point out all the reasons that a spring scale doesn't work, you might come away with the impression that it's a very silly tool and no one should measure weight or mass with one. In reality though, many high-precision scales that are used all the time are based on the level of compression of an internal spring. They're all over labs, kitchens, bathrooms, and they reliably give good results. Cherry-picking limitations of a measurement technique while ignoring all the times it is successfully used all over the place is dishonest. Since this is Snelling, no one should be surprised.
And so they knew that obviously the diamonds had inherited extra argon. In fact, they went in and found that there were bubbles in the diamonds, little micro bubbles, and there was argon in the bubbles. It hadn't come from radioactive decay of potassium.
Well, it actually may have, but it would be the decay of potassium in the mantle, because these specifically formed in an intrusive bit of igneous rock from the mantle, which, unlike things like extrusive lava flows, can't outgas as easily.
So we know it's an issue. Here's another interesting example. In the Grand Canyon, in the eastern Grand Canyon, we've got lava flows down the bottom there. They're called the Cardenas basalt.
Buck says he's going to talk about arrowheads.
They're in the rocks that were formed before the flood, or right near the beginning of the flood, just before the flood. And there are lava flows that are so recent that there's volcanoes still on the rim of the canyon. The lava's flowed down the walls of the canyon, and some of them you can still see congealed to the walls, and they blocked the Colorado River and dammed it up for miles, and the river burst through.
Is there a point coming? I sure hope so. I'm going to cut it until he makes a point. He just keeps going on and on with an anecdote about going down rapids.
Well, what is the rubidium-strontium age of these lavas? Here it is.
So this is more Steve Austin nonsense.
Steve Austin.
In fact, he's the only one I can find having reported a rubidium-strontium age of over 1 billion years. In fact, Dalrymple, whom you'll remember Snelling earlier referenced when talking about the rapidly cooled basalts of Hawaii, got rubidium-strontium dates of about 680,000 years, and he did so with dozens of samples from all over the Wincurrent basalts. Further, there are tens of thousands of radiometric dates from the Grand Canyon, all completely in line with real geology. Oh, but guess what? Once again, there have been reports of very old xenoliths in parts of this basalt, in this case zircons and monazites, which, if not excluded, erroneously increase the age of the sample, just like last time Austin came up. To continue the scale analogy, it's like Austin is leaning on the scale when he uses it, and then using the obviously wrong readings he gets from it to pretend that all scales are useless.
They've got the same rubidium-strontium age within the experimental error margin.
Yeah, that's the age as reported by Steve Austin. As I've already stated, when everyone else checks, they get about 700,000 years.
How could the youngest rock in the Grand Canyon, that's probably so recent that Native Americans saw the eruptions?
No, they didn't. This basalt is about twice as old as Homo sapiens as a species, so no humans saw it.
give an age of over 1.1 billion years, the same age as the oldest lava flow in the Grand Canyon.
Because Steve Austin is either about as competent at geology as an untrained slime mold, or because Steve Austin is an intentional liar who wanted to get bad dates in an effort to bolster his dogmatic belief that the Earth is some 750,000 times younger than we know it to be.
Why could that be the case?
Because if you're a creationist, you can't be both well-informed and honest. The degree to which you are knowledgeable and competent in a relevant field is the degree to which you have to lie about it to make it fit into a young Earth timeline. That's why Snelling will lie about fossils being from the flood when they're actually from a Cenozoic lake, which according to his own flood model, makes them post-flood. It's why Snelling will take as gospel the shoddy work of Austin, but ignore the tens of thousands of measurements from radiometric dating in the same areas that come up with consistent and entirely mainstream dates. It's because professional creationists have two options. The Todd Woods option of saying, yeah, I know the evidence is currently against creationism, but I'm going to try to fix that. And the much more common option of just lying.
The answer is that these lavas came from the same source.
No, they probably didn't, as evidenced by the fact that they do, in fact, have different radiometric dates. They probably come from similar sources, though. They're both basalt, after all, so at the very least, they both come from magma pools that would form into basalt if they formed extrusively, and gabbro if formed intrusively. That is, they formed from mafic magma. That is to say, less silica-rich magma with low amounts of gas and relatively low viscosity.
Most people don't realise that basalt comes from down in the upper mantle below the Earth's crust, and that means these lavas came from the same source under the Grand Canyon, and they represent not real ages, but they represent the chemistry of the same source.
Yeah, if you want to call all of the mantle the same source, but even under Snelling's flood model, the part of the mantle that formed these two lava flows wouldn't be the same. That's because he believes in catastrophic plate tectonics. For him, the Precambrian Cardenas basalt is pre-flood, while the Winkerid basalt is post-flood. Snelling teaches that before the flood, the continents were arranged into the supercontinent of Rodinia, and that during the flood, the supercontinent broke up, came back together into Pangaea, and then broke up again to form the continents as we have them today. So for Snelling to be right, that this similarity in dates is the result of both of them having the same source of magma, he would have to argue that 1. There is no outgassing of cooling mafic lava or other processes which would tend to reset a radiometric clock, which we know is not true. 2. That the material is chemically homogeneous across geographic distance, and 3. That therefore any basalt in the world should test the same age as the Cardenas basalt, and should all come out as 1.3 or so billion years old, according to rubidium-strontium dates. He does not, to my knowledge, say any of those things, so this explanation doesn't work. It also doesn't explain the thousands of perfectly concordant dates for the igneous and metamorphic rocks of the Grand Canyon, and even of the Winkerid Plateau basalts in particular. A more parsimonious explanation for this event of one worker getting a wonky result on his rubidium-strontium tests is that he's just a bad geologist.
Now, if that's the problem with, we know that these recent lava flows are recent, okay? If they give an age of over 1 billion years...
Which they don't, unless you suck.
How do we know that we can trust the old age?
Because those ages were established by competent, honest workers, and when they are put to the test in fields like mineral and oil exploration, they are used to successfully dig new mines and new oil wells. They also fit all other evidence like deposition and erosion rates that you get independently from simply studying things like geology and geomorphology.
You can go to different ocean islands around the world, Hawaii, Canary Islands, the
Azores, Midway, American Samoa, Guam, Tuvalu, the Marshall Islands, Tristan da Cunha? What?
Some of the other islands, the Ascension Islands, Easter Island, Reunion Island, etc.
I'm actually surprised and impressed that despite the fact that between us, Andy and I named a lot of islands, we didn't really have any overlap.
And you can take recent lava flows and you can test them for uranium lead, and you'll discover that they all give ages of between 1 and 2 billion years for recent lava flows.
Sure, it would be nice to get a citation for that, because I don't trust Snelling to tell the truth. So until he provides some reason to think he's right, I'm just going to conclude that he's probably lying, since he's a demonstrable liar who lies.
And this has been known in the geological literature for over 50 years, and it's called the lead paradox problem.
Yep, these particular lava flows are less likely to incorporate uranium as magma, and more likely to incorporate lead. This results in lower than otherwise expected levels of uranium compared to lead. This is a known problem with some oceanic lava flows, but it just means that you use other techniques to date it. Just like with the spring scale, if you're in a situation where you need to weigh something, but the spring scale might not work, say because you're in an airplane and the variable speed and direction of the plane makes recalibrating to account for the Sagnac effect impractical, you use a balance scale instead. Sure, it's not as convenient and it's more finicky, but it'll work in this situation. Every single form of radiometric dating has limitations. No one is denying this. The problem is that having limitations and not working aren't the same thing.
Now you see, if we can't date the recent lava flows accurately, how can we date the old ones, the older ones?
We can do both. Has Andy forgotten that we managed to date the Mount Vesuvius eruption to the exact calendar year? Cherry-picking edge cases doesn't negate that. In fact, Dalrymple managed to successfully date the Wynkoop basalt that Andy is just pretending has never been dated successfully before. When Andrew Snelling says that we can't date historical lava flows, or even geologically recent lava flows with radiometric dating, he's lying to you. And I know because he has published perfectly conventional work back when he was a consultant for mineral exploration companies, and his work then reported and depended on accurate dating techniques. He knows they work, he just doesn't like it, and he wants you to be confused about the topic so that you have the same moral and theological outlook that he does. Andrew Snelling fundamentally does not care about rigor, scholarship, or the truth. What he seems to care about is maintaining his identity as a particular kind of theologically and socially conservative Protestant Christian, and secondarily, making sure as few people as possible move away from that identity to a new one, and as a far distant third, trying to get new people to take on that identity. He will lie to your face if it helps him keep his identity or makes you more likely to share it.
Could they not also have had contamination and inheritance of these isotopes back from the beginning?
Yes, but that's why you check to make sure there is no contamination, by running multiple techniques.
I am programmed in multiple techniques.
You check to see if the rock might be one of those ones where it's known that some dating techniques are unreliable. You check for xenolith inclusions that might be throwing off your dates. And finally, and perhaps most importantly, the significance of many of the limiting factors to various radiometric dating techniques tends to drop off as time goes. So depending on how old the rock actually is, they might only be a minor problem in the first place.
You see, the geologists believe that the reason these lavas give 1 to 2 billion year old ages is because it reflects the chemistry of the mantle source. Well, wouldn't that be the case with the ancient lava flows as well?
No, because contrary to what Andrew Snelling thinks, the mantle of the Earth is not chemically homogeneous.
And yet they use these methods to date the ancient lava flows as millions of years old.
Or even billions of years old. And they use more techniques than just uranium-lead, which is the one actually affected by the differential uranium and lead incorporation in the magma. Or, maybe all geologists are actually just really, really dumb and never thought to investigate potential limits and problems with their techniques, except that, Snelling already cited Dalrymple doing exactly that. So Snelling knows that they do in fact know about and investigate such things. Remember, if you think you thought up some obvious problem that all the experts in the relevant field have just not noticed, chances are they have noticed, have addressed it, found it either wasn't a problem or how to get around it, and moved on. All before you even notice it in the first place. This is one of those cases. The only difference is that an uneducated layman can be excused for being ignorant of what's actually going on in the field in question. Andrew Snelling can't because he not only has a PhD in geology, but he's published real scientific work. He knows better.
What about contamination?
A rock that has had contamination will not tend to be contaminated in such a way that it affects multiple decay products and parent isotope ratios in a consistent way, such that all dating techniques will converge on a single but erroneous age. So if you suspect contamination, test the rock with as many techniques as possible. The weird outlier is probably contamination. If they're all discordant, then you probably have lots of contamination, and you should probably try a rock from a different part of the formation you're testing.
Here's an example from Colorado. Okay, and I've tried to make this simple. On the left, you can see that there's a granite.
Is this a real example? Because Colorado is a big place, and I'd love to know if this is based on real rocks that I could investigate, or if it's just Snelling's little thought experiment.
Okay, and it's supposedly 54 million years old. On the right is the host rocks. The granite came as hot molten material. It intruded into these older rocks that are supposed to be 1.375 or 1,375 million years old. Well, you know what? They found when they dated those host rocks.
Who found? What rocks? Just cite the source, man.
That they became younger as you went towards the granite. Why? Because the heat and the water that came out of the granite contaminated the host rocks.
Which is why getting samples from the middle of a formation is better than not. But also, I still have no idea what rocks he's talking about, so I can't even really say if this has actually happened. Given Snelling's track record, I'm skeptical, although nothing about this seems so implausible that the only explanation is that he made it up. You know who would definitely not get samples only from the surface of a rock and then only have them dated with a single dating technique? My subscribers. So why not like this video and subscribe to the channel so you don't become an idiot like Steve Austin, but also so you can keep up with all the content on the channel. Additionally, hit the bell icon and turn on all notifications so that YouTube can send you some of the notifications when I have new content. Because we all know they'll never send you all the notifications.
And so, we're not talking about small scale, we're talking thousands of feet of contamination from that granite.
Interesting if true, but how many techniques were used? Did they all give consistent ages? Was the age just linearly getting older the closer to the center of the formation one gets? Was there a cutoff? Were there noticeable chemical differences between the peripheral and the core of the intrusive younger granite? I don't know, because I don't know what rocks or study he's talking about.
So we know that water, hot water and heat can contaminate these rocks.
This is neither news nor an insurmountable problem.
Well, here's another interesting example. You know, the geology, and this is at the micro scale. We've got two grains of a mineral called biotite that are side by side, okay? And each of those stars represent an analysis that was done with a tiny little probe.
Again, what kind of analysis? Done by whom? On what rock? From where? When? This cartoon-looking visual probably wasn't from the original study. Where are the actual figures from the paper?
And they're measuring a thickness less than the size of a thickness of a hair, our hairs. And so they're doing essentially a point analysis. And what did they find? Okay, they did a sequence in this second grain. What did they find?
I have no idea because I don't even know what he's talking about. All I have to go on is that some group of who knows who is testing biotite for something. It's like I said to you, some people tested a car in 10 places. Guess what they found? How could you answer that? You don't know who is testing the car for what. Maybe they found consistent airbag deployment, or variable rates of loss of air from the tires, or transmission fluid loss, or who knows what.
They found that it got younger the further you went into the grain.
Well, at least I know we're talking about argon-argon dating. Did that happen with the other dating techniques? That's the kind of thing we'd need to know if this is going to be a problem for radiometric dating overall. Instead, all we have is the word of a known liar that this is a thing that really happened, and he's not even telling us all we need to know to assess the overall claim. This is like if that kid in school who always had to one-up every story anyone ever told, and who you're pretty sure made up most of the stories, one day came to you and told you that every day he's been trying to beat his personal record high jump, and that just yesterday he cleared 8 meters of height on a high jump. Yeah, maybe he did. But then you've seen him jump before and he has trouble clearing 1 meter, never mind 8. And also, he's not exactly a trustworthy source, and he refuses to demonstrate his ability or even provide evidence that this alleged 8-meter jump ever happened. Snelling needs to provide a citation or shut the fuck up.
Well, that's because you had contamination come along that boundary.
Yeah, assuming that this is a real thing, that makes sense. And again, is why you want multiple samples, ideally from deep within the rock, to minimize this problem. And also why you want to use
Multiple techniques.
These grains have got a sheet structure, and therefore there was contamination coming in there. So, you know, even the micro scale, we can see the effects of contamination.
I mean, if you can see it at the macro scale, then it should be pretty obvious that you can also see it at smaller and smaller scales. Not sure why this is a point.
Here's another interesting example. Granites, and I've depicted this here, have a mineral in them called zircon. It's called zirconium, the mineral is zirconium silicate.
One of the more common types of xenolith inclusion. Zircon has an absurdly high melting point of over 2,500 degrees Celsius or 4,500 Fahrenheit. Lava tends to be between 700 and 1,200 Celsius, so zircons basically never melt once they're formed. As a result, they end up in much younger rocks as older inclusions. If they are included in a test sample, they will skew the age of the sample much older than otherwise would be expected. The kind of thing we've seen in Steve Austin's work more than once so far.
It has uranium in it.
That's true.
And it's radioactive.
That's true.
Zirconium is a very important metal.
I mean, I guess it has some important applications in aerospace technology and high temperature industry, but it's not exactly as important as iron or copper.
And it's mined using zircon.
No, it's mostly mined as zircon, not using zircon.
But these grains form when the granite cools.
Nope, that's a lie. They were already there because granitic magma is generally not close to hot enough to melt zircons. They're simply carried into place with the magma as solid crystals. There's no way a PhD geologist doesn't know this. In fact, the temperature of rhyolitic magma, the kind that makes granite, tends to vary from about 750 to 850 degrees Celsius, or 1400 to 1560 Fahrenheit. Not even close to the 2500 degrees Celsius needed to melt zircon.
They form when the granite, so that you would think that the minerals in the rock would give you the same age as the rock as a total. If you took a sample of the rock and crushed it up.
No, I would absolutely not think that if you're including zircons, because they absolutely do not tend to melt and then recrystallize in granite, because granitic magma simply isn't hot enough to do that. So I would expect that if you included zircons in your sample, you would get older ages than expected. You know, the exact kind of thing that already happened repeatedly to Steve Austin. In fact, when Austin was making his blunders, he was working with basalt, which comes from magma significantly hotter than the magma that makes granite. So if anything, granite is even more likely to have the problem of old xenoliths a researcher must be careful to exclude from the samples to be dated.
You get the same result if you took one of the minerals and dated it. Well, here's what they get. Zircon grains in a Himalayan granite, supposedly 21 million years old, the zircon grains in it gave an age, uranium-lead age of 1753 million years.
Yup, if anything, that's younger than I'd have expected. Zircons can survive for billions of years and be incorporated into brand new rock being laid down this minute.
How could those grains be so old?
Andy knows exactly why. Now so do you, because I already explained it. He's just a liar.
Of course, they then say, oh, well, the zircon must have contaminated the granite. But wait a minute. We know that the zircon forms when the granite cools.
No, we know the opposite of that. Zircons are generally already there and are not formed in granite de novo.
It didn't get inherited from somewhere else, an older rock.
Yes, it did.
We see the same thing in Australia.
You're going to see the same thing all over the world because zircons are all over the world. And almost no magma is ever hot enough to melt them, so once they form, they just kind of stick around.
A granite that was dated at 426 million years by rubidium strontium had zircon ages up to 3,500 million years.
That's a weird way to say 1.35 billion. I guess since creationists are generally bad at math and specifically orders of magnitude, it shouldn't surprise me that they talk about numbers in weird ways.
That just doesn't make sense.
It makes lots of sense if you know the physical properties of things like granitic magma and zircon. Honestly, I didn't expect even Snelling to just pretend that there's no such thing as xenoliths. Perhaps I should have, but for some reason this feels like an unprecedented level of dishonesty. Then again, his target audience probably thinks that Xenolith is the name of a warrior princess who hung out with Hercules sometimes, so I guess he can get away with it.
These minerals were contaminated, and they've contaminated the granite.
No, they were not contaminated, although I suppose you could call them contaminants in the surrounding granite. But it's something that's routinely recovered from samples to be tested, as I pointed out, before even knowing that he was just going to lie about zircons. Also, some fun stuff about zircons. First, they are quite good at picking up uranium, but lead is largely excluded during their formation, although not perfectly so, meaning that they are good candidates for uranium-lead dating on their own if you want to know how old the zircon is, rather than the surrounding rock. And further, while it's possible for the decay product lead to leach out, this only occurs under the most extreme conditions that a lab can produce, far more extreme than what's likely to occur in any geological context, and even then the loss is extremely minuscule, meaning that again, uranium-lead dating of zircons tends to be highly accurate because we can confirm both that there was essentially no daughter nuclides in the initial crystal, and that essentially none of the daughter nuclides have left the crystal since it formed. So the fact that we can find billions of years old zircons is something of a problem for the young Earth.
Here's an interesting example, by the way, another one. A Himalayan granite, supposedly 20 million years old, contained zircon grains, one mineral, that gave uranium-lead ages up to 1483 million years. But they also had another mineral in it called monazite that's radioactive, and it gave uranium-lead ages of minus 97 million years.
You'll be interested to know, I'm sure, that this claim is in fact taken from a 1990 paper by Randall R. Parrish called Uranium-Lead Dating of Monazite and its Applications to Geological Problems. It is in fact an overview of both the uses and limitations of uranium-lead dating with monazite. One of the things it notes right in the abstract and expands on in the body of the paper is that monazite easily incorporates thorium-230, which decays to lead-206 and does so faster than uranium-238, which can give it erroneously young and even negative ages. It also loses lead more easily than zircon, and so taken together, while it can be useful for testing, Parrish is specifically noting corrections and limitations with using it to date rock. This isn't something that geologists are either hiding or unaware of.
In other words, minus 97 years old means that the rock hadn't formed yet.
No, it means that monazite incorporated thorium-230 in relative abundance, something it's well known to do.
Which is the correct age of the rock?
It's 20 million years, because you pretty much never use zircons to date granite because they are xenoliths and they are going to be much older than any granite they're likely to be found in, and the monazite is known to have this problem. And so unless you can correct for the excess thorium-230, which is possible in some cases but not all, you're going to stick with the granite age from the other minerals that both formed in the granite, unlike zircons, and also didn't incorporate excess of nuclides that also decay into lead-206, besides uranium. Which fortunately is the case, since most other nuclides that do that, such as thorium-230, are not often incorporated into those minerals. See, it's not just whatever the scientists want it to be. There are good reasons to exclude the dates from certain inclusions in a rock, and these can be corrected for and accurate ages obtained. Snelling isn't revealing something that actual geologists haven't noticed before.
Minus 97 million years?
Obviously not.
20 million years?
Yes.
Or 1483 million years?
No, that's the age of the zircons, which, while probably correct, is different than the age of the much younger granite.
Well, you pick the one that suits you, what you want, don't you?
No, this has nothing to do with suiting. You don't pick the negative age, first of all, because that's impossible. This probably isn't time travel rock after all. You don't pick the zircon, because those are known to be older than virtually any rock they're found in. You date the part of the rock that doesn't have known problems, and you do it with numerous techniques from different parts, and then 9,999 times out of 10,000 you get a concordant date with a reasonable margin of error across numerous techniques, and that's the date you go with. And when it's important that you get it right for mineral exploration or oil exploration, it turns out those dates can actually be used on the ground to predict where to dig successfully. Science is all about using present measurements and theory to predict future data, and where to discover valuable minerals and oil is an important prediction, one that's done successfully with the help of radiometric dating. There's a reason no big oil companies are paying people with dowsing rods to look for oil. It doesn't work. If radiometric dating didn't work to find oil, they wouldn't pay to have it done.
Here's another interesting example. Again, with a microbeam, a focused microbeam, so as the thickness of a human hair, they're actually dating a spot on this crystal, and when they rotated the crystal to date it on different faces, they got different ages. Here they are. The ages varied by 500 million years.
Depending on the age of the rock and the technique used, that might be an acceptable margin of error, especially if it's a very small sample, which will have a larger amount of uncertainty, simply because it's less likely to be a representative sample. Also, I would love to be able to look this one up, even if I have to search for keywords like I did with the Parrish paper, because God forbid Andy actually cite things like a scientist would.
On different faces of the same crystals, and they repeated it with multiple crystals. 74 analyses on 47 crystals. Well,
what crystals? Who were they? What results were found? What kind of crystal was this?
Crystal?
So far, this is just an anecdote, which isn't evidence in science.
I said before that there's evidence of accelerated nuclear decay or radioactive decay, and here it is.
So we're really not going to get any details on an example. We're just going to move past it. Okay, well, since there's no reason to even think it happened, given how dishonest Snelling routinely is, I see no reason to even address it beyond saying citation or shut up.
We're coming to it right now. We've talked about inheritance. We're giving you some examples. We talked about contamination. But here's the 4 major methods that are used to date rocks. And geologists usually only use one of those methods on a rock. They choose the one that's the most convenient.
I will contest this usually thing. It is true that often in an effort to keep costs down, only the most relevant method is used. But if there is any question about the validity of that method, it is fairly normal to use other methods. That's why isochron dating is even a thing. It involves multiple tests. What is the ratio of a single dating technique versus multiple? I haven't a clue, and I don't know that Andy has bothered to check either. That being said, if creationists want to say that rocks routinely vary in age based on which method is used, then they'll have to explain the fact that it actually usually isn't that way, and that isochrons routinely yield consistent ages.
Rarely do they submit all samples, their samples for all 4 methods.
Rarely is a weasel word. How rarely? How often should they do it? What problem is there with how frequently they do it now?
And the reason they don't do that is because they assume that no matter what method they use, they get the same age for the rock.
I mean, that's why they don't feel bad about doing it some of the time. But the reason they don't do it all the time isn't an assumption of accuracy. It's that grant money isn't infinite. No scientist gets to do all the testing he or she wants to do. They have to prioritize. And if there is no great mystery about the age of the rock, and the initial testing comes back with an age well within what might be expected based on things like stratigraphy and other dating of rocks nearby, etc., then why bother? But that doesn't mean that no one ever bothers. In fact, Snelling has, well, not cited, but alluded to papers in which scientists did just that to uncover the limitations of various dating techniques. Further, just because one worker dates a rock with one technique, that doesn't prevent other workers from dating the same rock with another technique. That's also something that happens. And yes, every once in a great while there's a discrepancy. And then a resolution has to be found.
And in theory and practice, they should.
And in theory and practice, all my viewers should go to my Patreon and pledge $1,000 a month so I can turn this channel into an actual production studio making on-location documentaries with famous scientists, voice actors, and artists. Turns out my viewers, quite rightly, aren't going to do that, because their resources are not infinite. And while I greatly appreciate them, I don't think they're all trillionaires who can drop that kind of money on some YouTube channel. Similarly, much as I might like to live in a world where every measurement everyone wants to make is free and doesn't cost anyone precious resources, we don't live in that world. I would love to reverse Thanos snap 1 billion testing machines for radiometric dating into existence, make electricity free and clean, and put 800 more James Webb Space Telescopes into orbit. If Snelling wants to spend his time running a bunch of what he thinks of as under-tested rocks through every imaginable radiometric dating technique, he's welcome to. Heck, he's even welcome to publish his results. You know why he doesn't? Because he's already done radiometric dating professionally, he knows it works. And he knows that its limitations are already well established, and that if he did this, he'd uncover nothing that would in any way shake the overall confidence geologists have in the techniques. Remember, Andrew Snelling is a liar.
Because it's like having 4 hourglass clocks stacked on the stage here, on the platform. Each of them have got different sized sand grains. But remember, we started with all the clocks having the sand grains at the top.
At least right when you flip them, sure. I'm not sure Andy understands how hourglasses work.
And in real time, the sand grains fall to the bottom. And so they should give you the same age, even though they've got different sized sand grains or different sized atoms.
So far, so good. Not sure why we need to go back over this weird analogy.
And so that's why they only use one or two methods. Well, we'd expect, what would we expect if we use all 4 methods? And so we did some experiments by collecting samples in the Grand Canyon, and we didn't just use one sample, we used multiple samples in a method called the isochron method because it gives you better statistics in your calculation.
A technique frequently used by geologists. Andy didn't come up with this. This isn't some new creationist thing.
And so what would happen if you used all 4 methods on the same rocks? Well,
if I did, I have no idea. I'm not trained as a geologist to know how to properly take or prepare samples for isochron dating, so I'd probably screw it up and get the wrong result. If creationists did it, well, we've already seen them on multiple occasions lie about the rocks and knowingly use the wrong tests on them and misrepresent sources, so I'd go out on a limb and say that rather than unintentionally screwing up, I'd expect them to intentionally screw up in a misguided attempt to discredit science. If a geologist did it, Well, I'd expect most of the time that they'd get concordant dates, which they do, and that occasionally they'd get discordant dates, which they'd then investigate. I wonder what Andy thinks will happen.
The Cardenas basalt, we met that before. Here it is, the lava flows. You can see that's the view from the Desert View Tower, which is the easternmost overlook point in the Grand Canyon. There those lava flows, and there they are up close and personal, and we collected them.
I wonder if that was before or after he was denied access to the canyon and then sued for religious discrimination with no actual evidence of such.
Something like 6 different lava flows. What results did we get? Potassium argon, 516 million years. Rubidium strontium, 1,111 million years. Samarium neodymium, 1,588 million years. Which one is correct?
Well, first, rubidium strontium and samarium neodymium are correct, because they're both pretty close, and this test had fairly significant margins of error. The age is probably about 1.3 billion years, give or take a couple hundred million. Second, remember when I said that creationists would probably intentionally screw this up? Yeah, turns out that very much looks like what happened. You see, one of the requirements of potassium-argon dating is that the rock in question not have been heated above the temperature at which argon can escape from the rock matrix. Guess what? In Austin and Snelling's own 1998 blog, yes, I'm referring to the Proceedings of the International Conference on Creation, a blog, because that's what it is, it's not a journal, post, reporting on this, they themselves say that some of their samples had evidence of alteration from heat, which means that they know very well that those samples can't be used for potassium-argon dating. And when you remove them from their data, all of a sudden, their isochron is concordant with not only their other tests, but with the actual dates reported by real geologists.
What about none of the above? How will we know without an observer? Notice that the potassium-argon age is the youngest.
Yeah, because he specifically chose samples that he knew would skew the results young, because they violated the necessary conditions for potassium-argon dating. I mean, what's the other option? He himself reported on the alteration of the samples. This was a knowingly deceptive attempt at a pretend paper published on a blog that lets pseudoscientists LARP as real scientists.
And the rubidium is young as the next youngest, and the rubidium is younger than the samarium neodymium. Well, let's look at another example.
Okay, we're not going to actually discuss that. I gave more details about this so-called study than he did, and he's the one who did it in the first place.
This is where the molten rock, instead of being erupted from a volcano, got squeezed like molten toothpaste between the layers under the ground and cooled under the ground.
Okay, so this is intrusive igneous rock. What are we talking here? Granite? Gabbro? Where is it?
The geologists call that a sill. And if you're ever driving in New York City and you drive on the Palisades Freeway, you'll pass one of these sills. It's called the Palisades Sill, there by the Hudson River.
Is that the one we're talking about, or is he just naming a random sill?
And this is actually 300 feet thick. Yes, we climbed to the top. Well, I climbed to the top.
I guess so. Way to climb, Andy.
And we collected samples all the way down. And what results did we get? Potassium argon, 841.5 million years. Rubidium strontium, 1,060 million years. Lead, 1,250. Samarium neodymium, 1,379 million years, which is the correct age.
I can't even seem to find the blog post he was referencing here, so I don't know what to say about the dates. But I can say that given the history he and Austin have of just lying in their blog posts that they pretend are papers, and since there's no reference here for me to check on, and since this whole thing is giving me a headache, I'm just going to say data or shut up, Andy, and move on.
How would you know without an observer?
The same way we know what the correct age is with the Cardenas basalt. We test it, and despite the fact that some lying liar who lies comes along and lies about it, that remains true.
By the way, notice the potassium was the youngest, rubidium the next youngest. What I didn't tell you before is that the lead and the uranium and the samarium decay by alpha decay, whereas potassium and rubidium decay by beta decay. They're different types of decay within the nucleus of the atoms. So in other words, the beta decays will give you younger ages than the alpha decays. That's interesting. There's a systematic pattern here.
Well, there might be, but we've only had 2 examples so far, and they were both from a source whose trustworthiness is somewhere between that of Kent Hovind and the disgraced 4 times indicted and hopefully by the time this video goes up, bankrupt 45th President of the United States. Even if I could trust Andy's numbers, 2 data points aren't enough to establish a trend.
And the other interesting thing is, the larger the atomic weight, the size of the nucleus, and the longer the decay rate, the bigger the age, the bigger the age. Isn't that interesting?
It would be interesting if that were actually established by quality data that had been cited. Instead, it was based on data from a known academic fraud, and even if it weren't, it's still based on too little data to draw that conclusion. It suggests an interesting avenue of research, though. I'm sure Snelling could devise an actual testable hypothesis about this, and then go actually do real work and publish in a real journal, not just a blog on the creationist RP server.
There's a pattern here.
Not yet, there's not.
And then we took samples of these rocks here that are metamorphic rocks. These are metamorphosed basalts.
Meaning that the argon had ample opportunity to escape, because to metamorphose basalt requires high heat, which is how argon gets to escape from rock. So we should expect the potassium-argon date of these to be young.
And we got results like this. Rubidium, 1,240 million years. Lead, 1,883 million. Samarium, 1,655 million years.
Well, at least he apparently didn't use potassium-argon, so way to go on that. But, what are the margins of error on this? I don't know, but those are all very similar ages, and my guess is that they would probably have some overlap in their margins of error that contains a true value. Or at least that was my guess before actually looking at the paper, but we'll get to that. Now, Snelling published this in the same blog as before, this time without Austin as backup. Based on what we know of Snelling already, let me know in the comments whether you think he used proper or improper methods. Spoiler, it was improper. You see, this rock is highly metamorphic, which means we know for a fact that you cannot simply date it via any radiometric dating technique just by testing bulk samples. Instead, because it is made of different minerals with different physical and chemical properties, each mineral must be assessed on its own to give a history of the initial formation and later alteration into a metamorphic rock. This is simply because as the rock heats up, various component minerals will lose various elements at various times, resetting their atomic clocks. Basically, testing each mineral can tell you the time at which it was hot enough for the exchange of relevant atoms. Testing them all together gives you random noise that barely correlates to anything. And when they are tested by other researchers, mineral by mineral, we get a consistent set of dates that correspond to a basaltic lava cooling about 1.7 million years ago, with metamorphism happening some 40 million years later, with each of the minerals having ages that fit well within the standard model given their known closure temperatures and the process of metamorphism. In other words, their discord goes away when you actually do the test in a way that is actually proper, and that won't just get you a bunch of crazy noise.
See, which is the correct result?
None of them in this case, because that test was fundamentally improper. That's also why this hasn't exactly made waves in the geochronology world.
What about none of the above when you didn't have an observer there?
It's none of the above, but not because there was no observer. That's a ludicrous requirement on the face of it, and not even Andy takes it seriously because he himself is trying to come up with an account of the unobserved formation of the rock layers under Noah's flood. If he were serious about the observer requirement, he wouldn't even pretend to do that because it would violate his own rules about needing an observer in order to know anything about the past.
See, if all these clocks were accurate, they would give you the same age as what we get for example, in the Cardenas basalt.
Yeah, if the rock wasn't highly metamorphic, they might. Too bad it is, and Snelling reported as much in his blog post.
Why would we get different ages? Well, if they were ticking at different rates in the past.
Well, since we know that that's physically impossible short of changing the laws of physics, and since we know that it would release enough heat if it happened to just vaporize the rock in the first place, we have two great ways to know that it never happened. But the real explanation is just that the process involved in the transformation of this basalt into its present metamorphic amphibole state resulted in various minerals resetting their atomic clocks at different times, meaning that bulk sampling will simply return nonsense, which it did.
Let me explain. In other words, if the potassium clock ticked rapidly through 16 million years, remember, these clocks all started at the same time.
No, they didn't, because this is metamorphic rock.
There was a real time period between when the rock formed and today. The potassium clock ticked through 516 million years.
I wonder if that has anything to do with the fact that the rock got hot enough to reset that clock.
While the rubidium-tronium clock ticked through in the same real-time period, 1111 million years.
Except it didn't, though, because each mineral started over during the metamorphosis at different times.
And the samarium clock in the same real-time period clicked through 1588 million years.
Except it didn't, though, because each mineral started over during the metamorphosis at different times.
So in other words, the decay rates were faster in the past.
No, in other words, Snelling is lying about how to do radiometric dating, what it means in metamorphic rocks, and also is using data that, on their own, show that there was no accelerated nuclear decay, because if there had been, it would have released so much heat that it would be obvious that the rock had been completely remelted. Which didn't happen. So just based on his own work, we have more than enough information to conclude that accelerated nuclear decay just never happened.
And we can explain this disparity in the ages by a systematic process that was going on to dealing with the strength of the nuclear forces holding. You know, God only had to change slightly the holding of the atoms within the nucleus, and it would speed up the decay rates.
Wow, I'm actually happy he proposed a mechanism. And that's the one that I also identified as the mechanism that could cause this. But let's remember that Snelling puts all of the Paleozoic and Mesozoic rocks as flood rocks. We can assume that the radioactive decay in, say, the Precambrian was just already there as part of God lying about how old the Earth is. That still means that we need to fit 470 million years of radioactive decay into about 1 year of time. That means everything needs to decay 470 million times faster than normal. That means you're going to need a drop in the strength of the nuclear forces that's sufficient to account for that. That wouldn't just speed up the rate of decay, it would mean that previously some nuclides that were previously stable would suddenly find that forces like the electromagnetic force are suddenly strong enough to make previously stable nuclei radioactive. We should see evidence of novel decay chains and depletion of nuclides that would be newly radioactive. We don't see this. Of course, there's also no mechanism by which to weaken the nuclear forces, but I guess we can take that one step at a time.
So if these assumptions are not correct,
which they either are or can be checked on,
then they can't possibly accurately yield absolute ages of claimed millions of years. So,
well, again, the ages would be absolute, even if they're wrong, because in this context, all the word absolute means is that the age is expressed in terms of a number and a unit of time, such as a year.
Assumption number one, all the daughter atoms is derived from parent atoms.
Which is not an assumption in isochron dating, and can be checked for. And the older the rock is, the less important this assumption is.
Violated by inheritance.
Yeah, which we can check on, as evidenced by the fact that Snelling himself cited Dalrymple doing just that in a real science paper, as opposed to a silly blog like the one that Snelling edits for Answers in Genesis.
No other processes have affected the parent-daughter relationship.
Which again can be checked for by doing things like sampling from different parts of the rock, not ignoring metamorphism, etc., and of course, ignoring metamorphism is something Snelling has admitted to doing on his blog, and then he pretended that his intentional misuse of radiometric dating was a problem for the technique. As if leaning on the bathroom sink while weighing yourself so you have a lower number on the scale was a problem with scales.
Violated by contamination.
Again, something you can check for, and I know Snelling knows this because he reported on real papers that were about detecting contamination in rocks.
Assumption number 3, constant decay rates.
Not only is it near as anyone can tell physically impossible to vary these, we don't see evidence of them having varied. Further, there are other possible implications of this. There are really only 2 ways to vary the nuclear forces, changing the coupling constants, or changing the speed of light. We don't know what the effects of the first would be, but the effects of the second would affect kinetics, chemistry, even time, all of which are tied to the speed of light. I guess then we can probably rule out a change to the speed of light, since so much of the creationist model depends on Earth surviving in a recognizable way. Which wouldn't happen if things as basic as mechanics, chemistry, and time were fundamentally altered.
Violated by accelerated decay rates.
Which again are impossible, and for which we have no evidence besides that it would make Snelling feel better if they were a thing. By that logic, I must have $1 billion in my checking account.
So by the way, you think about it for a moment.
Oh, I've been thinking about it way longer than that.
A lava flow that formed in the first month of the canyon, first month of the flood year, it's at the bottom of the Grand Canyon.
It's like he forgot his own flood model. The Cardenas basalt is from pre-Cambrian rock, which normally to Snelling means pre-flood.
It's gonna tick through a year of accelerated decay.
Great, I look forward to Snelling showing us all the things like decay halos from nuclides that were radioactive, but no longer are.
Whereas a lava flow formed at the top of the Grand Canyon in the last month of the flood, say, is only going to tick through a month of accelerated decay, so it will give a younger ages.
Yeah, sure. I'm not arguing that accelerated decay wouldn't leave the relative dates obtained by the radiometric dating intact. That seems reasonable. You should still be able to see which igneous rocks are younger or older, radiometrically, if you had just a universal decrease in the strength of the weak and strong nuclear interactions in the nucleus.
So that's why the results seem to be in a systematic order, because it reflects the order in which they were formed during the flood.
See, though, that also means that short of accelerated decay, then radiometric dating is reliable. Because in order for this to be the case, then the other so-called assumptions must be broadly applicable to the rocks of Earth. Otherwise, there would be little if any correlation between the date obtained and the actual age, regardless of whether decay was accelerated or not. Snelling is trying to have his cake and eat it too. Either the dates are reliable in terms of relative dating, and therefore problems like inherited daughter products and contamination are not problems to the technique as a whole, or those are problems for the technique as a whole, and relative dates are unreliable even under a young Earth creationist framework.
But the ages aren't absolute, they're just relative.
Well, he's doubling down, so I guess we really don't have to worry about contamination or inheritance, according to Snelling. Odd, then, that he'd spend so much of the first part of this talk complaining about them.
Well, the evolutionary scientists, why do they claim, therefore, and ignore these assumptions?
They don't.
Well, it's because they give them the result they want.
Nope, there's no reason to think that the scientists want particular results. Scientists are there to find out what the data indicate, and if you can show that their conclusions are unwarranted, you get to publish about that to their chagrin. Generally, scientists don't care if a rock is 3 million, 30 million, or 300 million years old. They just want to know the right answer as closely as they can. Remember, geology was started by Christians. They didn't have as a goal trying to disprove the Bible. It's just that what they found in the rocks disproved at least some readings of the Bible.
Okay?
No, it's not okay. Snelling just accused basically all of geology of knowingly committing academic fraud, which is rich coming from the guy who hid cracks in a rock by putting people in front of the visible cracks. That's a serious accusation, and there has been nothing put forth here, or ever, that would back that up.
And the isochron technique, that's multiple samples, eliminates the need to know the initial conditions.
Yes, it does, which means that one of his big objections just holds no water.
And supposedly indicates contamination.
Well, yes it does, which eliminates another of his big objections, bringing us down to just the complaint that we don't know if decay rates were constant, except that, yes, we do, because there's no evidence of a weakening of 2 of the 4 fundamental forces of the universe, which is something that wouldn't be exactly subtle if it had occurred.
But that's not always the case.
Oh? I hope we're going to be given some examples demonstrating this.
And the reason why they say the methods work is because they give them the ages they want. You see, think about it.
I am thinking about it, and this is literally a conspiracy theory. This is exactly the kind of anti-science thinking that is why so many creationists are anti-vaxxers, anti-maskers, etc. When you go around with absolutely no evidence accusing the entire scientific community of fraud, which is pretty rich coming from Snelling in particular, can there be any wonder that your audience will be broadly anti-science? The brute fact remains that when dollars are on the line, radiometric dating works. You can check for contamination, and starting conditions can be eliminated from the question. Spontaneous decay, the kind of decay that matters, cannot vary without changing the laws of nature, which itself would be detectable if it had happened. That's why scientists treat it as reliable, within the conditions and with the caveats that are known for the technique. It's not because old ages give them the warm fuzzies.
If there weren't millions of years, there'd be no time for evolution to occur.
True, but the average geologist couldn't care less about that. In fact, early on in the history of evolution, most old-age geologists didn't think the Earth had been around long enough, even if it had been around too long for young Earth creationists. And it's not like they changed their mind to accommodate evolution. That eventually the 2 branches of science, biology and geology, converged on mutually compatible histories of the Earth is not a point against them, but a point for them. There's no reason they should be able to do this other than that both models are reasonably accurate ways to describe the world and its history. Imagine thinking that corroboration from other parts of science is a bad thing, actually. Creationism really is brain rot. Snelling is blatantly peddling anti-intellectual conspiracy, and his audience is just lapping it up. I wish they were as good at critical thinking as they are at hiring graphic designers to design church logos.
Why did Charles Darwin's idea of evolution take off in 1859?
I mean, it didn't really. It had a lot of pushback from very famous geologists and biologists, including Sir Richard Owen and Darwin's own friend Charles Lyell. It's true that it had its early proponents in figures like Thomas Henry Huxley and the much maligned Ernst Haeckel, but it was not dominant, and while basic faunal succession and common descent was accepted somewhat rapidly, things like natural and sexual selection as dominant forces in shaping organisms wouldn't really be the consensus for decades into the 20th century, with people still, despite all the evidence supporting things like orthogenesis and saltationism, well into the early parts of the 20th century.
Well, it was because 20 years earlier, 30 years earlier, Charles Lyell had promoted the idea of millions of years.
Weird how no one noticed that it took years for Lyell to even start coming around to Darwin's side.
And Darwin dedicated his book on the origin of species to Charles Lyell, because without the millions of years, you can't get time for evolution.
Lyell didn't, at the time of publication, provide enough evidence for Darwin. In fact, Darwin notes as much in The Origin of Species in all editions until the last, when finally geology was proving less a thorn in his side. The more likely reason for a dedication is that Lyell was a friend of Darwin's, and while not a supporter of evolution by natural selection for much of his life, he had encouraged Darwin to publish his theory because A, he was by all indication a good friend who cared about Darwin, and wanted him to succeed, and B, just because a scientist doesn't think an idea is correct, doesn't mean he doesn't think it's worthy of consideration by his peers. Oh, also one minor thing, you know what The Origin of Species lacks? A dedication page. Lyell is thanked for his encouragement to publish and his help in getting that done, but technically the book's not dedicated to him. Just one more case of Snelling spreading misinformation. Granted, this is fairly minor, but still, it goes to show that you really can't trust anything Snelling says, no matter how trivial. If this guy told me the sky was blue, I'd go outside to check.
And that's why the age of the Earth is such a critical issue.
Except that, as we saw in the late 19th century, geologists don't really care, and if they thought the world was too young for evolution on the basis of the evidence they have, then they'd say so. And if that upsets evolutionary biologists, well, that's their problem. This entire conspiracy, like most conspiracies, is completely ahistorical.
Well, very quickly, how reliable and objective are the measured decay rates anyway?
Extremely, and let's remember, they're not just measured, they're also the predicted outcome of the most mathematically accurate branch of physics ever to exist, particle physics. For example, the decay rates of thorium-235 and uranium-235 were known with a margin of error of less than 0.2% and a confidence of 2 sigma, which is to say that the chance of an actual value being outside that range at all is about 4.6% or so. But the further outside that range, the less likely that value is to be accurate, which means that we have a very precise measurement of the half-lives. And while the confidence interval isn't exactly 5 sigma, it's also not at a level that would allow for the age of the Earth to only be 6,000 years old. But if you wanted to argue on the basis of the somewhat modest sigma value that the Earth was, say, 4.4 billion years old rather than 4.5 billion years old, I won't stop you. Indeed, it's also not like people aren't continuing to check this. 2 of the papers I looked at for this measurement of half-life of nuclides were published in 2017 and 2018. And what do you know, their results are within the margin of error of the established rates.
And there are 2 parameters by which decay rates are measured and expressed. There's what we call the half-life.
Just make sure you watch out for head crabs.
Okay, you've heard that expression, some of you, the half-life. Well, it's basically this: if you start with a pound of uranium, after 1 half-life, there's only half a pound left.
Well, only if the pound of uranium was all of the same isotope, which is nearly impossible, but sure.
After another half-life, you've only got 1/4 of a pound left.
Yep, importantly, you always get half the remaining part. It's not that after 2 half-lives the sample vanishes. Now, I know what you're thinking. Dapper. That's so obvious, why are you even saying it? Well, it's because I've had creationists directly tell me to my dinosaur face that after 2 half-lives, everything should be gone. That's how scientifically illiterate creationists can be. Now, granted, usually not the pros, but the fact that someone can be so into creationist literature and content that they'd want to defend the ideas publicly against me while being so scientifically ignorant should be seen as an indictment of the results of the project of creationism. It breeds scientific ineptitude at very basic levels. Creationism is bad for you. My hope is that I'm doing my small part to inoculate my audience against it.
And so it decreases with time. Okay, so that's a measure of the radioactive decay rate.
That's true.
And these methods, there's 3 methods that have been used to measure these decay rates. Yes, you can do it. You can do a direct counting. You can take a pound of uranium, you can stick a Geiger counter and let it tick for a year. Now, you all chemists know, don't you? The chemists know that there's There's Avogadro's number, isn't it? 6 times 10 to the 23 atoms in a mole.
If we're only doing one significant figure, then yes, that is the correct value.
Okay, so you can work out how many radioactive uranium atoms are in that pound of uranium. The Geiger counter measures how many decayed in a year, so you can work out the decay rate. It's not that difficult.
Broadly, because you need to isolate different isotopes, you're not likely to be using a whole pound of uranium, but that's not really all that important. I think that mass of uranium was included to be illustrative and easy to think about. So I won't come down on Andy for that.
And you can start with a sample with no daughters in it and leave it on the bench, and after a year you can measure how many daughters there are, and so that's what we call in-growth, measurement of the daughter isotopes.
Again, this isn't so much a correction as extra information. You actually can start with daughter product in the initial sample. You just have to measure its relative abundance at the start of the measurement so you can correct for it.
Or you can compare the radioisotope ages, and here's where it gets tricky. Let me explain this, okay? Over the last 70 or so years, they've tried to determine the half-life of potassium-40, and they say it's 1.248 billion years. But because there are uncertainties...
Which, remember, there are in literally all measurements of any kind.
How do they ultimately derive that number?
I don't know, Andy. How do they?
Well, they do it by taking a sample that they know the age of from uranium-lead dating.
A reliable technique that we've been given no valid reason to reject on the whole, provided that, like all measurements, the measurement is done correctly.
And if they get a different potassium-argon date, they change the decay rate for potassium to make the age agree with the uranium age.
If this were true, then the decay rate for potassium-40 should be fluctuating all over the place in the literature. I can't seem to find anything that indicates this. So, unless Andy is going to provide it, I'm going to have to conclude that he's lying. And of course, remember, the vast majority of radiometric dates are concordant, so this isn't even something that could come up very often. And given the ubiquity of concordance, the much simpler explanation for a discordant potassium-argon date is just contamination or leaching.
Well, that's a bit sneaky, isn't it?
It would be, but is it really going on? Also, hey, remember that time that Snelling showed his audience Green River Formation fossils and told them that they were too pristinely preserved to be the result of anything but a flood? Except that the Green River Formation is a Cenozoic lake bed, meaning that according to Snelling himself, they're post-flood? Kind of sneaky, isn't it?
That's a bit sneaky.
It would be, but is it really going on? Also, hey, remember that time that Snelling showed his audience Green River Formation fossils and told them that they were too pristinely preserved to be the result of anything but a flood? Except that the Green River Formation is a Cenozoic lake bed, meaning that according to Snelling himself, they're post-flood? Kind of sneaky, isn't it?
Well, here's another example.
There was no first example. There was just a bald assertion with nothing to back it up. So at best, this is going to be the first example.
Determinations of the rubidium-strontium decay rate, 48.8 billion years.
Quite the decay rate.
Well, they've used Earth materials and meteorites, compared with only 2 groups of analyses, and they've got differences.
They disagree according to his own source by a whopping 2%, and the indication is that the half-life is actually 2% longer. So tell you what, if Snelling wants to argue that the Earth is actually 4.634 billion years old instead of 4.543 billion years old, I won't fight him on that.
And so the only way they can reconcile these is by, again, taking the age of the known age by uranium-lead and adjusting the decay rate of rubidium so they get the samples to agree with the same age. Again, they're tweaking the sleight of hand here to change the decay rate determination
by 2%. This is exactly like if you and I drove separate cars on the same route from, say, Orlando, Florida to Seattle, Washington. We both reset our trip meters, and mine read 3,104 miles, and yours said 3,043 miles. Oh no, we disagree by 61 miles out of over 3,000. Okay, that probably means someone needs to check their trip meter, but then here comes Snelling to say that actually, because of this difference in measured drive distances, the more likely option is that actually the trip might have been 22 feet. You know, a distance that wouldn't even get you past a single building within Orlando. I'm not kidding. That is the level of difference between the measured age of the Earth and Snelling's preferred age.
To match so the ages agree. What we've just seen, there's evidence that the ages don't agree, but they're making them agree deliberately.
While the rock only has one age, and absent known reasons to doubt the better established age, the most likely cause of this is an error on the part of the previous estimates of decay rate. A much less likely option is that the laws of physics pulled a fast one, despite the fact that we know they didn't. And let's remember that ultimately the RATE team, which included Snelling, didn't actually provide a reason that radiometric dating couldn't work. They failed and just concluded that, I guess it was all miracles. Next, he just does a repeat of the same point, except it's samarium. I'm not going to go over the exact same argument again. At best, his argument would mean that we have to stop using rubidium and samarium in dating, which would still leave us with a billions of years old Earth.
That's not very honest at all.
Something Snelling knows all about.
What about uranium, which is supposed to be the benchmark? 85 years of direct counting. Can we be certain that the half-lives are accurately known? Well, the interesting thing is, they're not accurately known.
All right, let's see it.
And the problem is that the ratio of the two uranium atoms, 238 and 235, isn't precisely known, because what they've found recently is that there's very significant differences in that ratio in different rocks, meteorites, and minerals.
Okay, but we can test for ratios in a particular rock and then use that knowledge to correct for this. I'm not seeing a problem here. In finding that this is the case, the solution to this alleged problem is also immediately known.
And so that means all the uranium-lead dates are not accurate.
By how much? Is it another case of 2% or so? Should we say that the Earth is actually only 4.443 billion years old? Remember, Snelling needs the decay rate to be wrong by 99.9999%. He needs it to be off by a factor of 756,000. This is a man who sees a fishmonger and a customer arguing about the weight of a halibut, with one person saying it's 176 kilograms and the other that it's 178 kilograms, and then Snelling comes by to propose that maybe they should actually accept the mass of 230 milligrams. You know, because it's reasonable that a fish about the same size as a human might weigh as much as 10 strands of hair.
That's interesting.
It is interesting. It's also not going to help young Earth creationism.
Here's some of this variation. I don't have time to, but you can see there that there's a great variation in different minerals and different meteorites.
I guess the editor didn't think it important to include the slide for this one.
And so there's uncertainties in these decay rates.
Yeah, that's how science works. There's uncertainty in everything, but an uncertainty of a few percent isn't the same thing as leaving the door open for a factor of 750,000 error. No one is proposing decay rates that are like 6 orders of magnitude off from any measured ones.
And these two problems make all the uranium-lead dating subject to large uncertainties.
Ah yes, large, another weasel word. How large? I can tell you it's a few percent, not many orders of magnitude. Snelling really would be on the deck of the Titanic, saying that maybe he can stop the ship from sinking if he stacks enough newspaper onto the bow as it's going vertical.
And if that's the case...
Which I guess technically it is, just not nearly to a level that could possibly help a young Earth.
Then all the other determinations have uncertainties.
They do. This is just why is science. I guess despite himself having successfully published in scientific journals, Snelling just missed the most basic aspects of science. Either that, or he does know that uncertainty is in every measurement possible and ever made, and he's just lying to his audience about that very basic fundamental fact of science. What say you? Does Snelling have no more understanding of science than a 6-year-old, or is he a liar? Put your guesses in the comments.
And therefore, none of the radioactive dating is accurate.
Non sequitur. Your facts are uncoordinated.
As we said before, inheritance, contamination.
Things that can be checked for, and in some cases even ignored depending on the techniques used.
Non-constant decay rates make all the radioactive dating methods totally unreliable and unusable.
It sure would be nice if we actually had any reason to think that decay rates changed. We don't, though.
And therefore...
Radiometric dating remains highly reliable, in use in numerous industries, and an absolute defeater for young Earth creationism. But of course, let's remember that even without it, there's no way for the rocks on Earth to all be laid down in the last 6,000 years, or even the Phanerozoic rocks, only to be laid down in that time. The reason the young Earth was abandoned in the 18th century wasn't that radiometric dating was invented. It hadn't been. It's because just the evident deposition and erosion couldn't be squared with a flood and a 6,000-year history. Radiometric dating could be shown to be completely useless, and it wouldn't actually make young Earth creationism plausible in the least. Young Earth creationism is lying on the floor with a sucking chest wound, and here comes Andy Snelling to make sure he treats its hangnail.
They cannot provide absolute ages for all the rocks and minerals.
Yes, they can. Even if they're inaccurate, they still provide absolute ages, because that's just an age expressed with a number and a time unit, which is what radiometric dating does.
The age of the Earth was determined assuming an unobserved evolutionary history.
Absolutely not. The theory of evolution factors into none of this. Quantum physics, chemistry, and geology are uninterested in the variation in allele frequency in populations across generations. The concordance between all of them is just evidence that our models in all of these cases are broadly correct, not a sign of some conspiracy.
That is, regarding the meteorites, that is contrary to the explicit statements of God's word, as I said before.
More's the pity for God's word, I guess. Reality is prior to the Bible, and the Bible is contingent on reality. Therefore, it is reality that is the metric by which to measure the Bible, not the reverse.
Well, as we draw to a close, I want to quickly talk about...
Draw to a close? There's still like 25 minutes left. This feels like going to a Vesper service, and the priest says, "Let us complete our evening prayer unto the Lord," except that the service is only like a third done.
Other methods that have been used to date the age of the Earth. All scientific methods, by the way, are based on unprovable assumptions, even the examples I'm going to give you quickly in a moment.
Yeah, empiricism is itself an unprovable assumption, but the fact that science keeps working means most scientists and even non-scientists just don't care.
What we do is we choose a process whose rate can be measured in the present. We assume certain starting conditions which we believe are reasonable, but we can't prove them because no scientist was there to see them.
Actually, you can demonstrate them because the past is indeed something that can be investigated from the present. Something Andy agrees with because otherwise he couldn't develop a flood model of geology, and yet he is trying to do so, meaning that fundamentally he thinks that eyewitness testimony is not necessary to know things about the past.
And watch them. And then we assume that the rate has been constant. The rate has been constant with time.
No, we don't assume that. We check to see if there's good reason to think that it has or has not been. An example is carbon-14. We know for a fact that the production rate of carbon-14 in the atmosphere has varied over the length of time for which carbon dating is useful. That's why there is a calibration curve for it.
Even though we weren't there to check those decay rates with time, and I'm going to illustrate this so you understand what I'm talking about.
We no more need to be there for billions of years to watch decay rates than we need to watch a giant redwood grow from a seed to know that's how redwoods come into being.
All processes can only ever give a qualitative maximum age for the Earth. There is no absolute scientific proof for the Earth's age.
I mean, short of last Thursdayism, sure, you can give a minimum age. If it took 5,000 years for a tree to grow, the Earth couldn't be younger than that. If it took 4 billion years for a zircon to get to its current level of potassium and argon, then the Earth can't be younger than 4 billion years old. The only other option is that God just poofed the universe into existence exactly as if it were, in fact, as old as it seems to be. In that case, there's no scientific difference between age and appearance of age, so the only rational thing to do is to carry on talking about the old age.
And so there's been many methods that have been used to date the Earth historically and can do so today.
This beating around the bush is getting exhausting.
What most people don't realise that only 10% give an old age.
I'm still going to need to see a citation for that. Who wants to bet most of examples for dating are actually not ways to date anything at all?
Over 90% give a young age. Let me give you a few quick examples. Comets. Comets are essentially dirty snowballs.
Oh boy, here we go. This is going to be dumb.
They're ice and dust. So when a comet comes past the Earth and comes around towards the sun knocks off some of the ice and dust, and that's what streams out behind it, shines as the tail. And so the comet is actually disintegrating.
That's true.
And most of the comets we've watched, we've seen them come back, and that's why Halley's Comet is not as spectacular every time as it returns, because it's progressively disintegrating. And the comets are said to be as old as the solar system itself.
Yes, but we know for a fact that their orbits approaching the sun are not that old. This is just figuring out how long a comet can persist in a sun-grazing orbit once it's in one. This tells us nothing about the age of the solar system, unless of course Snelling wants to argue that gravity isn't a thing, because that's the only way to make this work.
But the lifetime of these comets is less than 10,000 years.
Only after their perihelion is lowered to below the frost line. Until then, their lifespan is more or less indefinite.
After 10,000 years, they should have all been gone.
After 10,000 years, I'm free!
But there's still some around.
Yup, because there's this little thing called gravity, which means that when comets that don't approach close to the sun interact, one of them may have its perihelion lowered. Then subsequent interaction with bodies like Saturn and Jupiter tend to lower it to inside the inner solar system. That's why the only way for this to work as a dating mechanism is if Snelling can show that there are no comets that do not approach closely to the sun. We happen to know from both observations as well as mathematical analysis that at least two reserves of comets exist, the Kuiper Belt and the Oort cloud.
So that means the solar system is less than 10,000 years.
What you just said is one of the most insanely idiotic things I have ever heard. At no point in your rambling, incoherent response were you even close to anything that could be considered a rational thought. Everyone in this room is now dumber for having listened to it. I award you no points, and may God have mercy on your soul.
The Earth has a magnetic field.
That's true.
It's generated by electric currents in the Earth's core, and with real-time measurements have shown that the strength and energy of the Earth's magnetic field is getting weaker and weaker, halves itself every 1,400 years.
Weird that he's willing to say that when he's not willing to allow that level of reliability to radiometric dating, given that the rate of radiometric decay is determined by the fundamental forces of the universe, whereas the strength of the magnetic field is contingent on the state of Earth's interior, which is very subject to change. One group of people that are subject to change but won't be used fraudulently as a pretend dating method by creationists are my subscribers. Why not check to see if you're subscribed right now, and if you're not, go ahead and subscribe. Also, check to see if you have all notifications turned on. While you're doing that, please feel free to like this video, as it's one of the few ways the algorithm here actually notices me.
So in other words, 1,400 years ago, the Earth's magnetic field was twice as strong as it is today.
Well, yes, if the rate is constant. Is it?
We also know that the Earth's magnetic field reversed during the flood.
Oh, okay, so Snelling knows it isn't constant, so this makes it useless as a dating technique on its own.
Why? Because all the movement of the lavas inside the Earth, the molten rock coming out, that affected the balance of the Earth's magnetic field and it changed direction.
In order to do that, it had to drop to zero strength momentarily, then come screaming back, meaning that the field strength of the Earth's magnetosphere can go up in absolute terms. Again, meaning that we know that a simple half-life for the field strength simply isn't something we can extend into the past.
So here's these, and so that would also cause a more rapid loss of energy.
Non sequitur. Your facts are uncoordinated.
I'm going to need a citation on that, because most of the energy actually comes from nuclear decay, and field reversals aren't going to change that.
And if you look at these historic measurements, they confirm a rapid loss. If we go back in time...
If we go back in time using a chart in which there are no units labeled and there is no citation for the study being used to make this chart. Yeah, okay.
And we can check this. We can take magnetic particles in pottery that we know the archaeological age of and biblical age of, and we can test the magnetic field that was there when the potter made the pots, and we know that it was stronger in the past.
We do, but we also test magnetic field strength in some igneous rocks, going all the way deep into the planet's past, and guess what? There is no overall weakening trend. But also, notice how Andy is okay with using present rates and measurements in the present to infer the past state of a system without an eyewitness account? I thought that was something that creationists didn't like to do. I guess it's just something that they don't like when it doesn't suit them, but when they think it does, even though it really never does, then they're okay with it. Nice double standard there.
And so if we go back in time, the Earth's magnetic field back 10,000 years ago would have been as strong as a magnetic star.
Which is physically impossible short of the Earth being condensed into degenerate matter made of nuclear pasta. So we know that something is wrong with this model.
Well, that doesn't make sense because the Earth wouldn't be able to cope with a magnetic field that strong.
Yep, which means that it doesn't work. And the fact that we can measure the field strength deep into the past and that there's no overall 14,000-year half-life, this whole thing is a moot point.
So the maximum age of the Earth from the magnetic field decay is only less than 10,000 years.
No, it means that you can't use the field strength of Earth's magnetosphere to calculate its age.
What about the Earth's oceans?
I'm not the biggest fan, but that's because I was in the US Navy helping murder people for no reason on the other side of the globe, all while being abused by the government I was trying to support. I guess that's not actually the ocean's fault, but it still means I don't really ever need to be on the ocean again.
They're getting salty. All that salt that gets washed down by rivers ends up in the oceans.
Hey, fun fact, the rate of erosion is variable, which means that the rate of salt going into the ocean is also variable. But I'm sure there will be even more problems with this.
And we can figure out how much salt is going in and how much salt is coming out of the ocean.
We sure can.
And we can take sodium. Sodium chloride is common salt, but there's other salts. And we can figure out that the Earth's oceans, if we start, as they say, with a freshwater ocean,
which we probably can't, but okay.
Which they claim is 3 billion years old. But wait a minute.
I'm waiting.
The salt we got today in the ocean would get there in a maximum of only 62 million years.
If we assume that the rate of salt entering the ocean and leaving the ocean was constant, and that the former was higher than the latter, we know all of those things to be false. Creationists love to project things that we know we can't into the past indefinitely, while rejecting doing so with things that we know can be so projected. Spontaneous decay is based on the fundamental and, as far as we know, unalterable forces of the universe. It's probably something that fluctuates. Salt accumulation based on things we know to change like erosion, subduction, and chemical processes? Probably been the same unalterably since time began.
But wait a minute. Wait a minute. Would God have started with a freshwater ocean?
I don't know, man. I'm not a theologian.
No, he made saltwater fish.
How does Snelling know he didn't just make freshwater fish and then later some of them adapted to saltwater? I mean, if the oceans are getting saltier, as he says, which they're not really in the long run, but whatever, then they have to adapt to increasing salinity either way.
Okay, so we're probably wrong about the initial assumption of a fresh ocean. See, this is what I mean about you got to assume the starting conditions.
Is he just doing the job of debunking this for me? I mean, it's okay if he is, it's just a weird thing for him to do.
And then, remember I said that erosion takes salts and puts them in rivers that takes them down to the ocean. It makes it saltier. When would there have been a lot of erosion that put a lot of salt in the ocean?
The Carnian pluvial event, when it rained much more than typical for like 2 million years?
During the flood.
Right, I forgot. We're in fantasy land of physically impossible events, unicorns, and violating the laws of physics for funsies.
Most of the Earth's salt, the salt in the ocean, probably got there during the flood.
I disagree. I think it was actually the body fluids of all the aliens that the galactic overlord Zeno dropped into the Hawaiian volcanoes 1 trillion years ago.
So that age of 62 million years is way, way too big because it's based on the wrong assumptions. But that's a maximum qualitative age.
Except, that it's not, because salt goes out of the ocean. What it's actually measuring is the average stay time for sodium chloride in the Earth's ocean, right now. That's it.
What about biological materials? You've all heard about the dinosaur soft tissue?
Nope, not doing it. I've done this one so many times, I'm not doing it again. Suffice it to say that there are preservation mechanisms which were unknown, but are now well known, and that the tissue isn't soft until after it takes a nice long acid bath. And Mark Armitage has never actually demonstrated that his Triceratops even was a Triceratops. I'm skipping this one.
And then radiocarbon.
Oh good, we can hear about more examples of someone doing a study to show the conditions that mean that you can't reliably carbon date something, which Snelling then pretends invalidates the technique in all other cases. One fun thing, though, is that creationists like to use carbon dating for things like biblical manuscripts, because it shows that the manuscript evidence for what the text of the Bible is rather old, and really pretty good as ancient texts go. And that's true. The Bible has an excellent collection of manuscripts, and there's very little question in virtually every case as to what the text said originally when it was compiled or composed. Of course, they'll then turn around and poo-poo one of the reasons that we can say that about the Bible, because the same technique shows that many organic materials are far too old for the young Earth creationist timeline to be true.
You know, we took, and I did this work too back in the 1990s, but during a project that I was involved in, we took 10 coal samples from all around the US that were stored in a Department of Energy repository under special conditions to preserve them. And we sent them for radiocarbon dating, and they all got the same radiocarbon age, even though they were supposedly millions of years old.
Yeah, so a few things. Coal generally comes from fairly deep underground, a location known to have radiation that can induce the creation of new carbon-14 from nitrogen-14. Further, all the coal creationists tested came back with a radiocarbon age at basically the maximum for the technique. So it's a bit like measuring the mass of your car on your kitchen scale, and then concluding that I guess your car has a mass of only half a kilo, since that's how high the scale reads. Even though that's the maximum value it can read. Further, many creationist tests actually didn't test directly for carbon-14, but rather they checked for beta decay, which in some cases can be a reasonable proxy for carbon-14, but in the case of something from deep underground that could have all sorts of other radioactive nuclides in it, many of which decay via beta decay, it is not a reasonable proxy.
Most people don't realise that if every atom of the Earth was radiocarbon, it will all be gone in a million years. There'd be none left. That's why they don't date dinosaur fossils with radiocarbon.
That's, I suppose, one of the reasons. The real reason is that carbon-14 dating only works on original organic material, and by and large, dinosaur fossils are not original organic material, but have had all of their original material replaced by minerals that have taken the shape of the original organic material.
And yet the interesting thing, every fossil that's been tested, every coal sample, every oil sample that's been tested has got radiocarbon in it.
That is interesting, in that it's interesting that there are induced nuclear reactions going on underground, but then that's something we've known for a long time. Also, though, we have the same problem that we had with Austin's Windcurrent basalt testing. The test chambers for carbon-14 testing can't be completely evacuated, so they always give an age somewhere around the maximum age, even if you load them with no sample at all. So in some cases, it's actually not clear that these samples have any carbon-14 at all, although some of them probably do.
Which means those materials aren't that old.
No, God! No, God, please, no! 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 No!
And when you consider the Earth's magnetic field was stronger in the past,
which is not broadly true,
that affects the rate of radiocarbon formation in the atmosphere.
Good thing that's well known, and we have calibration curves to account for it.
And so those ages are even way too large.
No.
The interesting thing is we found that no matter whether the coal sample was supposedly 40 million years old or 300 million years old, it had the same radiocarbon age. Why?
Because they were abusing the techniques in an effort to dishonestly discredit them.
Because they were all trees that were alive the day before the flood.
Yeah, I suppose that's a possibility too, as long as you ignore the impossibility of the flood as Snelling thinks it happened.
They all died at the same time, so they should give you the same age.
Except that the age is way too old and is conveniently right at the maximum age that you could possibly get, which means that really the age given is use another measuring tool, because this one is maxed out.
And you know, diamonds, we've even looked at diamonds that are supposedly 1 to 3 billion years old, and they've got radiocarbon in them.
Everything I said about coal and fossils applies to diamonds.
They're the hardest known substance that can't be contaminated.
Diamonds don't block neutron radiation in any meaningful way as a result of being hard. What is Snelling smoking? It must be some real good shit, because being hard doesn't stop nitrogen impurities from becoming carbon-14 when they're hit by a stray neutron. And of course, these two gave dates at the maximum range of carbon-14 dating, meaning that the results are basically what you get if you tested literally an empty chamber.
What about, why are there so few human fossils, by the way? And there's no human fossils from before the flood because God said he was going to utterly destroy man blot him out.
Does that mean no fossils? That seems like a reach to give a flimsy textual reason for the otherwise unexplained absence of human fossils from what Snelling thinks of as flood rock, which is not at all what we should expect from a worldwide flood wiping out human civilization.
Why are there so few Stone Age human remains?
Because human bodies don't normally persist indefinitely.
They say that the Stone Age lasted for 185 million years. You know.
Excuse me, the did you just say?
Who said that? Homo sapiens hasn't even been around a million years, and hominins for less than 7 million years by most estimates. How could the Stone Age have been going on for 180 million years longer than hominins have even existed? What the is Snelling talking about?
We'll come to this in a moment, but how long did it take to produce the 8 billion people that are alive today?
300,000 years or so.
Not very long at all. So where are all the Stone Age fossils of humans?
Museums and in the ground.
We don't find their graves.
Yes we do. See what I mean about how dishonest this is? The existence of human remains from the Stone Age is well known. They're in museums all over the world. I've seen some of them in person.
Where are their remains? We only find thousands.
I'd love to see the math on that.
And so I could go on. All these methods.
Don't it all work as dating methods for the age of the Earth? I agree.
By the way, I should have told you. Okay? What about the human population? I didn't include this, but I'll add it.
Oh god, it's about to get super dumb. Get your face protection.
If you start with Noah and his family 4,500 years ago, with a growth rate of human population growth rate slower than today's rate, you get the population today in all that time.
Yeah, but only if you use the basic compound interest exponential growth formula. We'll assume a starting population of 6 because it seems like Noah and Mrs. Noah didn't have any more kids. So this works if the population growth rate is between 0.47 and 0.48%. But what does that mean if for the population of the Earth when Abram leaves the city of Ur and travels to Egypt in Genesis? Well, according to the Answers Research blog, Abram left Ur some time after 2900 BCE, but before 2750 BCE. We'll use the later date to be nice to the creationists. So 440,000 minus 2,750 is 1,650. We'll plug that into our population growth formula, and we find that the whole Earth had 16,200 people in it. That means that we have to divide that population between cities like Eridu, Uruk, Ur, Ashdod, Asilah, and that's just a few of the ones in the ancient Near East. There were cities in India and China, and the Americas were full of people, not to mention Egypt. If we just assume that Mesopotamia, China, India, and Egypt were the only civilizations, and that there were no people just living outside of the civilized area, which we know isn't true, then all of Egypt had at best 4,050 people in it, themselves split between several cities. Heck, that would mean that a good guess for the population of Ur when Abram left would be under 1,350. Actual population estimates for Ur, for most of its history, are more like 65,000 people, which is, almost 10 times the population of the whole Earth according to this stupid argument.
If evolution were true and man evolved 1 million years ago, there ought to be one person on every square foot of the Earth's surface with 16 other people stacked on their shoulders.
Yes, because there are literally no constraints on population growth, besides just how many people there are having sex at any given moment in a way that can result in pregnancy. That's how this works. Hey, let's apply this to rabbits, which conveniently are not kosher. So we start with only 2. Now, rabbits give birth sometimes up to 2 times a year, but we'll only go with once a year, and they have between 5 and 8 kids. We'll take the lower estimate. That means that every year the rabbit population will grow by a factor of 2.5. So let's plug that into the formula. 2 times 2.5 to the 4,400th power, and oh look, it breaks my calculator and just gives me an infinity symbol. In fact, if rabbits work the same way Snelling thinks that humans work, then in only 7 years there will be 7.2 times 10 to the 278th power rabbits. There are only about 10 to the 80th power electrons in the observable universe. Maybe it's the case that simple population growth formulae don't actually work in the real world in the long term. You see, there are things like famines, wars, plagues, etc. Also, environments have this thing called carrying capacity. which is the maximum number of any particular organism that an environment can support. Obviously, the Earth can't support more rabbits than there are electrons, so it never will. Similarly, the Earth can't support 10 to the 611th power humans or even close to it, which is the number you get if you put 300,000 years into the calculations with a 4.7 per annum population growth into the formula. So no matter how old humanity is, they won't even get close to that.
Where are they all?
They never existed, because populations don't just smoothly increase over time, because that's absolutely insane and would even invalidate young Earth creationism.
So you see, many of these methods give a young age.
Too bad none of them hold up to even a microgram of scrutiny, though, isn't it?
All scientific evidence for the age of the Earth, as I said before, involves unprovable assumptions. There were no human witnesses there to check those assumptions.
It's like he's the incarnation of hypocrisy.
All these methods can only ever give you a maximum qualitative age.
Okay, buddy, you keep thinking that.
Our only certainty is the God-breathed eyewitness account in the scriptures of the Earth's age and history.
I thought unproven assumptions were a bad thing, though. But only if they're the unproven assumptions that Snelling likes.
So why should the observations of the world around us by finite, fallible, fallen humans, interpreted by rejecting the authority of God's word, be given precedence over the clear statements of God's breathed eyewitness account in the scriptures?
Because that's where all the evidence points. It's really that simple.
And you see, this is where I take issue with Christians who have compromised.
I don't care. I'm skipping all this whining about Christians who have decided to not be blatantly wrong about reality. I'm skipping his theology stuff. I don't care about it. I will say he managed to discuss the creation of humans without going into overt transphobia, so that's nice. Credit where it's due. We're skipping to the Q&A because the next, 5 minutes was nothing but preaching.
Okay, so I take the boys to the the Field Museum, and we've got all the dinosaurs and all the big layouts and 40, million different artifacts of saying this is 300 years old, 300 million years old. How do I explain to the boys, oh, this whole place is wrong?
Don't explain that, because it's not. Just accept the science. It's that simple.
Well, you have to say that these are man's ideas about the age of these fossils.
You know what? No, this is my channel. I'm not going to let Snelling advocate for lying to children on a platform I control. Sorry, time for the next question.
Yes, that was a pretty detailed explanation of rock dating, and I think we're probably all here in the minority on the education of that.
What does that even mean?
So it would seem to me that the scientific community should have an overseer of a committee that could validate or invalidate rock dating methods, because it seems to me that that whole scientific dating method is askew.
It does. It's called peer review.
And needs to be reevaluated. So why isn't that happening? And are you the only Christian geologist? There's got to be some kind of grassroots effort.
There are, in fact, many Christian geologists. It's just that they're basically all old earthers because they're neither stupid nor liars. In fact, when he actually does geology work, Snelling is also an old earther.
Well, there's other Christian geologists like me who believe in God's word and the flood and the creation account.
Right. Liars and frauds like Steve Austin.
The interesting thing is that the geologist community trust that those who do the rock dating are very, very minor group.
The geologist community trusts that those who do the rock dating are a very, very minor group. That's not a meaningful phrase.
And they've got world-class laboratories. I mean, they've spent millions and millions of taxpayers' dollars building these laboratories, I can tell you that now.
Better that than the well over $1 trillion spent by the USA on killing people across the globe. So,
And so the analyses are very good, and most geologists don't understand these problems. They've never been shown that there are these problems.
No, they understand them very well. That's why they write about them. Like Dalrymple. It's just that they're not the problems that Snelling has to lie to make them out to be. None of this is hidden. That's why Dalrymple and his colleagues publish in real journals, not online LARP blogs with strict formatting requirements, like the Answers Research Journal. Okay, after this, he just keeps lying about the geochronology field, just not knowing about things that they themselves write about, which is so bonkers, I'm skipping the rest of it because it's boring. It's a lie, and frankly, I need to get to the end of this because it's starting to make me go a bit crazy, which is a surprisingly frequent thing that happens when I'm finishing up a script.
You touched on it a little bit, but why are there no human fossils?
There absolutely should be if most humans, around the time of the flood, drowned in it. The flood preserved delicate insect wings, according to Snelling, but it couldn't preserve a single human? That seems to beggar belief.
Okay, well, because God said to Noah, and he repeated it, that he was going to destroy the earth with man.
So God miraculously erased the evidence of the flood? I mean, that's certainly a take. I think it gives all the more reason to reject the historicity of the global flood, since that kind of a god is epistemic poison. But hey, if Snelling wants an omnipotent version of Loki as his god, I can't tell him not to do it.
And it says the Hebrew says he was going to blot man out. Okay? Now remember what happened to King Saul? He was told to go and wipe out the Amalekites.
So just doubling down on magic.
We don't do that here.
I'm skipping the magic stuff.
The only hint we get is in some parts of the geologic record, we get phosphate rock. There's places where it's mined for fertilizer. And the phosphate rock has the same composition as our teeth and bones.
That kind of stretch would make Mr. Armstrong proud.
Stretch him 4 times his size.
So it's possible that when the fountains of the great deep broke open, they were hot volcanic waters that were acidic. They dissolved all the human flesh and the bones. And then when they went to cooler areas, the phosphate precipitated out in those layers. I don't know.
So why did this only happen to humans? Why do we have any body fossils at all? Shouldn't that have happened to more or less everything? Are humans particularly susceptible to acid damage, but all dinosaurs have acid resistance? Do we need to update the D20 stat blocks for dinosaurs?
But we've got to be honest with the evidence.
Well, when Snelling does that, he manages to publish real papers. Too bad for him, they all support the old Earth, because let's be honest, he knows better. He's just a liar.
God hasn't left any record of the pre-flood world of humans. No record of civilization. There's no genuinely verifiable artifacts or human remains from the pre-flood world.
Because it never existed, because there was no flood. That's the takeaway from that.
All the human remains that we find are in the superficial layers that represent the people that lived after the flood.
Superficial is a cool word. Also, that's the only human remains we find because humans are recent arrivals on Earth. It's that simple. We don't need convoluted acid miracles to explain this.
And by the way, I know it takes up an extra minute, but in Africa, you find the primate fossils.
The oldest primate fossils are actually in North America, but go on.
In layers below where you've got the human remains. Well, what happened after the flood?
Noah got super drunk and cursed one of his kids for pulling up his robe to expose his passed out dad's junk.
People disobeyed God and stayed at Babel, but the animals dispersed.
Weird then how, despite the fact that the plain of Shinar is in Mesopotamia, that the oldest human remains are in Africa, which is also where the majority of human genetic diversity is. It's almost like this story directly contradicts the actual evidence.
So the animals got to Africa first, and then the humans later. That's why they're buried in that order.
Oh, so that's why there are no animals buried lower than the first humans in the Middle East, right? Oh, wait. That's not right. Oops.
And the geologists come along and say, oh, this must have evolved into this. No, they were just buried at different times.
Well, I guess that's it. I'm pretty disappointed in how that ended, but then I almost always am. So we got a whole lot of Snelling pretending that well-known limitations of a technique invalidate the technique, lying about a conspiracy to defraud the public out of the knowledge of the truth of the Bible, and a bunch of made-up dating techniques that do nothing to actually establish the age of anything, let alone the Earth. That's it. Oh well, if you enjoyed this video, then please feel free to hit like, and if you didn't, then feel free to hit dislike. Either way, let me know what you thought in the comments, and subscribe to the channel if you haven't. If you subscribe now or are already subscribed, check to make sure that you have notifications turned on so you're always notified when I have new content. I'm the Dapper Dinosaur. Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Ben Tovend, Felgevara, Tapioca Weasel, Whispers, E2V, Strawberry Vein, Denny5252, Elron Teller, Horseflesh, Ian Chen, Kelvin Brostick Van Manen, Landon Knoll, Mabbity Babbity, Monkey Day Them, Sphincter of Doom, and Volus. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.